And we are going live. Testing 1, 2, 3. How's the audio? Am I good? Am I in sync? Can you see me? Hello, hello. Few seconds of latency. Yakub says this is the right stream for Markin's anime jazz concert, right? Cool. Excellent. Yeah, I've got the microphone a little bit like off to the side here with a noise gate on it, so it might be a little bit choppy. But hopefully it's clean enough. All right, so here we are. Welcome to the first community stream for the Linux on M1 project. Thank you everyone for dropping by. I see we have 100 odd people. Ooh, awesome. All right, so let's get started. First of all, the project has a name. Name unveil. The name for the overall project community and eventually Linux distro for Linux on the M1 will be Asahi Linux. And before I tell you why it's Asahi Linux, I'm going to give you a few minutes and see if anyone can guess why I'm calling it Asahi Linux. Wait, you're saying I'm doubled, Ridley? I don't think so. Hold on. Ridley says I might be doubling myself, and now she's got me, wondering if I have a bad connection somewhere. Oh, wait a second. Yeah, she knows what she's listening for. How about that? Is that better, Ridley? Does it sound better? Yes, that's what happens when I forget to undo some jack connections before loading a new patch bay and something stay behind. Excellent. All right, so as I was saying, the name of the project is going to be Asahi Linux. Any guesses? People are saying beer. Well, there is an Asahi beer, there is an Asahi newspaper, there's also an Asahi ISP. There's a lot of things in Japan. And nobody's sponsoring the project, though. But Asahi is a very common thing in Japan. However, there is a very specific reason why I'm calling it that. Damage Boy says because it's sweeter than an apple. Well, actually, you might be getting somewhere. I'll give you a few more minutes to think about it. But anyway, there is a GitHub, what do they call it? Like a project. It's github.com/Asahi Linux, where we will have all the forks of all the software that we are developing on, and also some community stuff, some webpage things and documentation. Will probably just be in a GitHub wiki, and eventually this will also be a distribution, which is just going to be a simple downstream remix of Arch Linux ARM. Like I have no reason to create like a whole new distro or anything like that. But the point is that especially because these M1 Macs kind of have a somewhat special boot process and installation process, most likely. Even though I am going to upstream everything that I do, it's going to take a while before other distros incorporate it, and it's going to take even longer before they tweak their installers to actually work on the M1 in a useful way. And so the idea is that I will be providing basically images and install scripts that you can just use to install it easily, once we get to the point where that makes sense anyway. But it's just going to be an Arch Linux ARM, build with some pre-configured stuff and some pre-installed packages. So you're not going to need anything strange. Anyone who's used Arch Linux will be completely familiar with it. So the reason why it's called Asahi Linux, and it does indeed mean morning sun. But the thing is, Asahi is also the name of a specific variety of apple in Japan, and that variety of apple is what we know as the Macintosh. The apple that gave the Mac its name. So quite literally, Asahi Linux means Apple Mac Linux. And there you go. But also, yes, it starts with an A and AS, and you can make some word plays with that too, so that's handy. So, what I'm going to do today is I'm going to go over the process that I'm expecting to do, what the milestones and what the progression that I expect the project to follow. And I've been taking questions from patrons. And I will also be answering questions in the chat, but I'm going to prioritize Patreon questions. And what I've done is I've basically sorted them in order of the, sort of the chronological order in which I want to talk about things. So I will be interjecting the Patreon questions as I talk about the project. But first of all, thank you to everyone who helped sponsor this. Thank you to all the patrons who are helping make this a reality. I've done Linux ports in the past. I've have experience doing this, but getting this to work on the M1 and getting it to work well and getting it to support all this hardware well, and especially the GPU, is not a hobby project anymore. That's, as I said, it's a full-time job, and I wouldn't be able to do this without all your help. So thank you so much to everyone. And thank you especially to a few people who went above and beyond just being patrons. Thank you to Ryan Hodek, who made a huge contribution to the Patreon. Seriously, I can't thank you enough. Thank you to Ben Stalhut II, who sponsored this Mac Mini. Thank you to Drew Fisher, who sponsored a MacBook Air, which is still on the way because it's back ordered and should arrive next month. And thank you to Patrick Bernier for sponsoring this Mac Pro. So with this, MacBook Pro. So with this, we have the trifecta. We have all three machines. And this isn't just so I can test on all three machines, but actually I basically need at least two machines to make good progress. And the reason for that is that I will be working on running Linux on one machine while I test and experiment with things in macOS on another machine. And if I had to reboot every time, that would just make everything 10 times slower. So that doesn't make any sense. At least since I have this MacBook Pro right now, this is going to be the macOS machine for the time being. You can see my microphone in the reflection there, actually. Hello. And the Mac Mini, which is over here, is going to be the first victim or the first target. So the first machine to run Linux on the M1, unless someone beats me to it, is going to be this Mac Mini right here. So BJ asks, are you aware of any other porting efforts? Is it possible to coordinate efforts? Yes, there are. So there are some things that other people have worked on in the past because the M1 shares hardware with some of the iPhone chipsets. There was an iPhone Linux project way back, and there's also the Sandcastle project by Corellium. There are some interesting drivers in that kernel that might be useful. For example, there's an APFS file system driver. I'm not sure how complete, but it has a lot of code. So that's probably convenient. And I'm not sure how much of the, like storage and things like that will be applicable to the M1, but I will be obviously using anything that already exists that is upstreamable and properly licensed because I'm not going to waste time rewriting things that someone has already written. But as far as other people porting Linux, I'm aware of other people who want to experiment with other approaches to running stuff on the M1. There's one team working on using a hypervisor-based approach so they can run also Windows and things like that. Not under macOS, but like a bare metal hypervisor thing. And as I said on Twitter too, I will be documenting all of the hardware things that I find out. And of course, the code will be open source, so anyone can take it and work on it, use it for any other project. And like, I'm not doing this, like, this is not a one-person job, right? I'm working on this as an open project. Everyone can see my progress. Anyone can contribute. Anyone can join in. It's really a community thing. Also, BSD folks have also mentioned interest in this kind of thing, and anything that I write that is not, that doesn't have to have another license will be like MIT licensed. I'm not going to only GPL license anything. For example, the M1 GPU code will be MIT licensed. And that is already the case for the vast majority of the Linux graphics stack, which some of the BSDs also use. So this will also be usable by the BSDs for that reason. BJ also asks, are there specific tasks or projects that you hope someone else starts working on since they do not play to my strengths? Well, anyone is free to contribute on anything they find interesting. And I fully expect, for example, some other Linux GPU developers to at least join in on an advisory role, if not actually helping with the porting. But really, it's kind of up to everyone, anyone who feels like they can, give a hand on any particular area, especially once sort of the very low-level bring-up is done, because that's kind of a thing where there's not much room for collaboration until a kernel runs anyway, and I have a lot of experience with that. But once we get, a kernel that can boot and people are working on drivers and stuff like that, yeah, absolutely. Is there a high-level summary that describes the differences between booting on native metal and virtualization? Well, I can tell you right now. So, as some of you may have seen, Linux already runs on the N1 in a VM. My friend Alexander Graf demoed Windows, and Linux also runs on the same software under macOS. But the thing is, VM under macOS is virtualizing the CPU directly. So the CPU is natively virtualized, and you get effectively almost 100% of the performance that you would get on bare metal. But everything around the CPU, all the peripherals, and even the interrupt controller, but also the GPU, everything else is complete, has nothing to do with the physical M1. And so everything is going through macOS. And that's fine if you just want the OS to work, but you're not going to get, for example, 3D acceleration working properly. Or if you do, it's going to be, going through multiple wrapper layers, and it's not going to make a lot of sense. So VMs are fine if you just want to run the OS in a box for some purpose. But if you want to use a machine as a Linux machine, as your native, OS, it doesn't make it, a lot of sense to stick it in a VM, boot Mac OS, and then just full screen it and always use it like that. It's kind of silly. So that's why I'm interested in doing a bare metal port of Linux to the M1. I'm going to go through the chat a little bit, see if there's any interesting questions before I move on. Someone asked if future streams will be available on other platforms. I'm focusing on YouTube right now because I think most people are familiar with it, and I already have a channel with some subscribers. But I feel like it's a better fit than Twitch for this kind of work, perhaps. But I'm not sure. I mean, I'll take any suggestions. Shiz asks, can it run to AutoOS? We're gonna have to ask Doug Klang about that. And can I run Gentoo like on PS4? Yeah, sure. The reason why I'm not doing a Gentoo port initially, well, first of all, I mean, Gentoo will just run, ARM Gentoo will just run just like Arch Linux ARM. The reason why I'm using Arch Linux ARM is that I don't have any ARM build machines, and I don't fancy the idea of, recompiling everything while I'm trying to port to a completely new platform. I have a very nice Gentoo build machine for my x86 stuff, which I use for all my Gentoo machines, and Gentoo is my main OS. But Arch Linux is a lot easier to sort of recreate, throw around, and build on. And I also expect people to find that a bit more, handy. So, Gentoo is fine for people who like to run Gentoo, like myself, but I wouldn't want to say if you want to have a good Linux experience on the M1, you need to run Gentoo and compile all of your software, because that also kind of goes a little bit against the whole battery life idea, right? If you need to install something in the field, and it involves compiling it. So I think Arch Linux ARM is a good choice for getting started. But again, there's nothing specific about that distro choice other than I will be providing it myself, because anyone is free to take whatever distro they want, and ARM distros should just work as long as you install the kernel and whatever patches to packages that haven't been upstreamed yet that are required. So, yeah. Did Apple react on this project in any way? There is no reaction from Apple, and I do not expect one, knowing their PR team. Omar Darwis asks about contributing as a newbie. I think for any newbies watching, anyone who finds this kind of project interesting, and I know what that is because I've been there many years ago, I would say keep an eye on everything. Follow. I will be doing development streams. I will be commenting on things. I will be pushing things regularly to the GitHub, and so watch what I'm doing and see if anything that I'm doing sounds like something you might find interesting. Or if I'm working on, say, drivers, but then we also need, for example, perhaps some user space tools, then you could also offer to help with things like that. Or even just building things like install scripts or just testing. Basically, It's a very large scope project. There is everything from kernel code to like user space daemons, most likely, to install scripts and everything like that, and even just configuration and testing different hardware. So yeah, like anything that isn't being done that you think should be done, anything you can contribute to, by all means. John Kelly asks if I'm planning on emulating GIC. No, I am planning on reversing the IIC and adding support to Linux. I considered both approaches, and I think that Linux belongs at EL2, which means Linux is running natively on bare metal, because that's the other approach that that has been thrown around, is a sort of having a really tiny hypervisor for Linux to run on to make life easy. That's fine, but it's kind of not my cup of tea, so I'm going to do a native port, and that means adding AIC support. All right, there's a bunch of other random questions, but I will be moving a little bit first with the process, and if there's any questions that I didn't already cover while going through everything, at the end we'll have more time to just answer everything. Cardell just asks, Linux runs at EL1 currently. Linux can run at DL1 or EL2 depending on what platform you're on. So that's how you get Linux virtualization, like KVM on ARM, is you run it at EL2, if I remember correctly. Or was it EL1? I keep messing up the levels anyway. There's the trust zone thing. Was that EL2? Anyway. Yeah, if EM was EL1, then it's EL1. But actually, I'm pretty sure Linux doesn't care if you run it at like EL2. So yeah, we don't need like a trust zone shim just to run Linux anyway. I don't even know if these things do trust zone properly, to be honest. That's what I do. KVM code in EL2, okay. Yeah, but I mean, yes, but what I mean is that like you boot Linux at EL2, and then it'll drop itself to EL1, but that it's effectively that's its own choice, but you're booting it in EL2 so it can access hypervisor features. So that makes, yeah. When I say running in EL2 mode, I mean booting in EL2 mode, like whatever Linux implements afterwards to run at EL2 or EL1, that's up to Linux. This is actually the first ARM64 machine port that I do. I'm more familiar with ARM32 and PowerPC, and from the PS4 x86. So there's going to be a lot of sort of covering details like this, but it's going to be fun. Basically, every platform that I've done a Linux port to has been new in some way, shape, or form. So yeah. All right, so let's go through and start talking about the process. So how do you go on putting Linux on a brand new machine, especially one that you do not have documentation for? Well, the first thing that you need to do is, first you need to know how the boot process works. So thankfully here, Apple has given us a nice little entryway into the system, which is that we can run our own kernel instead of the macOS kernel. And that doesn't necessarily mean running Linux. It means running a binary file that could be Linux or could be something else, that is supposed to look like macOS to the bootloader. So at least it has to respect the same interface that the bootloader expects, which means it's going to have some form of command line arguments. And I think they have their own version of a device tree and stuff like that. Now, the thing is, trying to make Linux fit into that form factor natively doesn't make a lot of sense. For multiple reasons. It doesn't make a lot of sense because the upstream guys are probably not interested in having a whole little Mac only wrapper thing in the upstream kernel, but also because it's a lot more convenient to have some kind of bootloader, especially because the way that these ARM Macs boot and let you boot your own kernel is that you actually basically whitelist a single kernel binary that is allowed to run on the hardware. So if you wanted to upgrade the kernel, you'd have to re-sign it through macOS, which is a pain in the ass. And for development, you'd have to go back to macOS every single time you want to test something, which is completely insane. So what I'm going to do is have multiple steps before Linux for practicality, and because that way I can adapt the boot interface from what macOS expects to what Linux expects. And so step 0 is finding a serial port, because in order to get anything working on a machine, you need some kind of handy debug connection, and a serial port is the most low-level one you can usually get that is reasonable. So, oh, sorry. Brandon Pelfrey asks, "What do you envision viewing your milestones?" Well, this is basically what I'm talking about now. Kind of the progress. So, hold on as I explain. Artemis Tosini asks, "When you're initially getting Linux booted, how do you plan on getting output? Is there some UART you can sniff or an EFI frame buffer?" Well, I mentioned the UART, which is a serial port, and in fact, there is a UART. So, on all of these Macs, we have these Thunderbolt ports. And these Thunderbolt ports are not just your typical Thunderbolt port because Apple has some interesting custom modes on these. And I do know that one of them will expose a serial port to the outside. But even though some people have gotten this to work, nobody has documented it. So I get to reverse engineer it myself. And that is why I showed previously on Patreon that I got these little chips. And I also happen to have these little Type-C breakout boards. Because, as I understand it, the way you enable, you tell it to pull up a serial port, is that you need to send some custom USB PD commands. The way Type-C ports are configured is they have some little special lines that run a very annoying protocol because this is USB. That lets you do things like configure power supplies for how much power they're supplying, but also which one is supplying, like which side is supplying power to the other side, and a bunch of other things. And one of the things you can do is switch modes. So that is going through these chips, which are USB PD physical layer interfaces. These are FUSB 302, if I'm not mistaken. And you need them because the protocol is hideous analog. Like it's a digital signal, but the levels are not like normal things, and the tolerances are ridiculous because the USB spec is completely insane. Like every single thing about USB is insane, and USB-C is even more insane than everything else. And that is why I need these chips, because these will handle all the low-level details for me, so I don't have to build like an entire custom-level physical layer interface from scratch. And then I will just connect into probably an Arduino or something, so I can just run the protocol, because the timeouts are pretty fast, so you can't just plug it into a PC and like thumb it through USB. And in order to figure out what commands I need to send, I'm going to be reverse engineering the firmware of the Type-C controller on these Macs, which is at least the sort of like part that goes on top of the ROM is available in the firmware updates. Besides this serial port, which is going to be the first thing I need to figure out, and that's probably going to start happening basically next week, starting tomorrow, there is a frame buffer. The bootloader, in fact, does put up, the Apple logo on the screen, and we can just use that from Linux. So we don't need to do pretty much anything in order to get the graphics to work to the point of showing stuff on the screen. Linux already has a driver for dumb frame buffers like this. That doesn't mean that you can't, like hot plug an external screen or change resolutions or do anything. You literally just get what you get from the bootloader, but you do get an image. So yeah, graphics are basically done for us at the most bare minimum level. And so the first step is getting the serial port. I mean, I could use the frame buffer as a debug output, but that's not very useful because you also kind of want an input, right? The idea is that I want to be able to load Linux externally, so I don't have to keep copying things manually. And so the first stage is writing a loader that can load code from the serial port. The second stage is writing a loader that can load a kernel via USB, because the serial port is too slow to keep copying kernels, multi-megabyte kernels over 15K baud. So that's fine for experimenting. And this stage of the project is probably going to be based on something I wrote ages ago for the Nintendo Wii called Mini, which is a very simple bare metal ARM32, which I will port to ARM64 framework. And and it's basically minimal. It has like minimal exception handling and memory management, but it also has effectively a remote procedure call interface over serial. And this is very convenient because it means I can run tools on a PC and remotely control the Mac as sort of a puppet, effectively. So this is very useful for reverse engineering hardware, because if you're booting a whole OS and you mess up something about the hardware, most likely the whole thing is going to crash. And if you have a very minimal OS and you can recover from exceptions, then you're going to save yourself a lot of reboots. And so this is going to serve dual purpose as a Linux bootstrap loader and a hardware investigation tool. So basically, yeah, I'll have to port it from ARM32 to ARM64. I don't expect that to be terribly difficult because the whole thing isn't really much code anyway. And there's not a lot of assembly in there either. And then I will be adding a USB driver of some sort to that so that I can use that to upload kernels faster than over serial. So those are going to be the first 3 stages. Find the serial port and make sure it works. Make a serial loader and port mini so that I can do some basic experimentation, and that get the USB port to work so that I can have a faster communications channel that I can get that I can copy Linux from. Let me just check the comments a little bit. Yes, debug accessory mode. And I do wonder if the there's an official debug accessory mode, but like on these chips, it's not entirely clear exactly what gets pulled out to the Type-C port. So that one can be enabled with just a resistor, but I get the feeling that that's not what gives us serial on these machines, that I need a custom one of the custom commands, but we'll see. I will try that first before wasting my time with the PD commands. Let's see. Interface, accessory mode. Oh, this is available on, as far as I know, everything that Apple puts out with a Type-C port, including the iPad and the other T2 Macs and everything else. All right, so moving on. So Richard Zach asks, I wonder if using the JTagulator on an M1 Mac Mini could find any debugging ports, which could help with figuring out the bootloader to OS transition. I bet the debug ports are there, but not with a pinner connector, hence the JTagulator. Might have the pins far apart to discourage customers messing around with it. Well, unfortunately, that's not going to work because, in fact, you can get the JTAG port as SWD the exact same way on these Thunderbolt ports, but unfortunately, that is all going to be locked down because these are production devices, and Apple does not allow JTAG on production devices for security reasons. So, that said, you mentioned the JTagulator, and I will say, don't use the JTagulator. The JTagulator is a device, and there's a different device that is cheaper and does about 1 million other things that the JTagulator does not do. And this is going to be me shamelessly promoting something I worked on for a couple minutes. This is a Glasgow. This is another Glasgow. The Glasgow is a hardware multi-tool that is designed to be extremely powerful and simple to use for effectively hardware hackers or anyone who wants to mess around with protocols. What you have is a USB interface at 480 megabytes per second. That's an earthquake, I think. I'm sorry, I just got one of those emergency notifications on my phone. Let me just check that. Yes, 6.3 where? See, this is what happens when you live in Japan. Oh, it's up at the north. There's nothing here. But that's pretty strong up there. That's near Fukushima, actually. Anyway. So, going back to Glasgow. What we have here is a USB interface chip. 480 megabits per second USB 2. You actually get about 42 megabytes per second of real throughput on this. An ICE40 FPGA. And 2 banks of 8 I/O pins. And each bank is fully isolated from the FPGA with level translators that you can configure from 1.2 to 5 volts at any voltage between those 2 extremes through built-in voltage regulators that are software configurable. And the idea is that these ports are effectively protected so that you cannot break them. Well, I mean, you can break them if you like plug them into like a 12-volt power supply, but like plain short circuits and things like that are not going to destroy anything. And there are protecting resistors, and there is like ESD protection circuitry. So unless you literally pump a ton of power into them, you're not going to kill it. And so this will do, I think, about 150 megahertz of I/O performance on these pins. But the coolest thing about Glasgow... Oh, and it also has pull-ups, by the way. Software configurable pull-ups on every pin. Or pull-downs. But the coolest thing about Glasgow isn't just that, it's another FPGA board with some I/O pins and a USB interface. It's all the software. This is all based on the open source ICE40 toolchain that was reverse engineered. And the cool thing about this toolchain is that it is extremely fast. You can get designs built for FPGAs in like a couple of seconds. And so Glasgow is written in Python and uses NMyGen, which is a Python embedded hardware description language that compiles to Verilog, that then compiles to the hardware. And so you write Python scripts that include both the host code and the FPGA code in one script. And because the compilation is so fast, you literally like there's caching for like the last used bit stream, and that's it. If you change any settings, then you just build a new bit stream. And so that makes it a lot easier to develop because you don't have to worry about like configuration systems and registers and things like that. You just hard code everything where you pass the settings to the Python and the Python builds a bit stream with those settings hard coded, which means instead of writing Verilog configuration code and state machines, you're just writing Python. It's so easy to write tools for this. And all the scaffolding is done for you. You get the pins on one side and you've got an input and an output FIFO on the other side, and you write whatever you want inside to talk to them. And so we have applets for, of course, basic I/O and logic analyzer mode, but we also have things for I2C and SPI. There's a nice serial port mode, which does completely automatic baud rate detection. Not the sort of you need to type an 8 type, but you feed it any serial bit like baud rate, and it just guesses it and makes it work. There's the JTagulator clone thing, which guesses JTAG pinouts. There is things for flashing AVRs. There's things for flashing, a bunch of other microcontrollers, like some Nordic semiconductor stuff. There's, of course, JTAG. You can pass it through to OpenOCD, and there's also some native JTAG stuff, and a whole bunch of other things I forget. There's even things for driving like WS2812 LEDs. You can run up to 16 strings at really high bandwidth. So yeah, you should keep an eye on this. This is open hardware, and you can make your own if you really want to. I did the PCB layout for revision C. This is Rev C0, this is Rev C1. Rev C0 was interesting because the magic of open hardware is that anyone can take your GitHub repo and clone it and order some PCBs. And so I was working on revision C, and I forget who it was. I think it was Greg Davil, who said, "Hey, I just ordered some Glasgow PCBs," and I said, "Which commit did you order?" Thankfully, that commit wasn't too broken, and we retroactively tagged it Rev C0 so we could keep track of what it was, and he was nice enough to send me one of these PCBs. So that's what you can see as there's a few bodge wires in there. If this decides to focus, probably doesn't. There you go. But Rev C0 basically works. Rev C1 is the first production version, and Rev C2 is basically cost reduced and optimized for manufacturability. So Rev C2 is going to be what is going to be getting manufactured, but Rev C1 is the same, effectively, functionally, with very few differences. So yeah, check it out because it's a very cool project and very useful. I probably won't be using it too much for this. I expect to use the serial port and maybe logic analyzer modes to work out the like which pins of the Type C port have the serial port while I'm looking for it. But unless there's some hardware hacking that I have to do, that's probably going to be the extent of where I need Glasgow. But for anything with hardware hacking more deeply involved, or if I ever need to like logic analyze anything on these Macs, yep, definitely check it out. And Shiz mentions that it has a cute anime girl in the back. It indeed does. Wonder if anyone recognizes who that is. Though this one has a white silk screen, so she ended up black, and she looks like some kind of like evil version of herself. So, all right, moving on from the low-level bare metal stuff. Once we have the code running and the ability to load a kernel usefully enough, we have to move on to actually running Linux. And the thing about running Linux on a new platform, even one with somewhat custom peripherals like the M1, is that it's not actually that hard. You can basically, all Linux needs to run on a CPU is a CPU that it is compiled for, and a bootloader or whatever, some way of jumping to it that sets things up properly, an interrupt controller, and a timer. Those are the two things that you need, the two drivers that you need in order to run Linux on something and have it boot. Presumably you want at least a serial port too, so that you can like get some output and do anything with Linux. And that's not that hard. I was actually bored one night and ported Linux to the Wii's security CPU, not the main CPU, the security CPU, which has a bespoke interrupt and timer. And yeah, I mean, it's not that hard. Now, obviously, the hardware on this is going to be more complicated, and Apple, instead of using the standardized ARM GIC interrupt controller, used their own AIC interrupt controller. So the very first step is going to be reverse engineering that, which will probably happen through Mini, because that's the kind of thing that is ideal for debugging this kind of low-level hardware. And once I have that figured out enough to get basic interrupts working and a timer interrupt working, then I'll write a Linux driver for this. And I mean, you can actually like start booting Linux without an interrupt controller, and like you'll see there's like a distinct point of the Linux kernel boot process where some people might remember the whole calibrating delay loop and all that kind of stuff. Like that's where it starts using timers and interrupts. And so if you don't have those, you can kind of get about that far and get the really early boot messages, but it's not going to be able to schedule anything. So that's where it breaks. So once we have that, the next step is, well, the screen will basically just work because, as I said, the bootloader gives us a frame buffer. So I can just point Linux at that and we will have dumb graphics. And the next thing after that should be USB. And the reason for that is that USB is almost certainly completely standard. So once interrupts work, it should be very easy to get USB to work. And USB gives us, well, the ability to use any USB peripheral. So that's very convenient because then I can have like USB network, USB storage, anything like that. So at that point, Linux will, in theory, be usable on the Mac Mini. With external storage and external network and no acceleration for anything, but it should be able to run a desktop, and that should not take that long, judging by going by my experience with this kind of project. Now that's a very small amount of the work, but it shows you just sort of how much useful support you can get without that much work. Now after that is where the bulk of the work is. So moving on, once the kernel boots and we get to that point where we have basic USB stuff, and that will also involve probably some level of messing with the Type-C controllers, so we'll see about that. But I think Linux already has a driver for a very similar TI chip to the one that Apple uses on these Macs, so hopefully I can just mess with that and get it to work. And once we're there, we can move on to some drivers. But first, Jason Borisov asks, do you intend to expose an API under Linux for using the total store ordering mode that the M1 has for compatibility with the x86 memory model that Rosetta uses for good performance? I think it would be cool if this was exposed under Linux and made available to open source software so that QEMU, Wine emulators could potentially add support and benefit in similar ways to Apple's Rosetta. Absolutely. I hadn't actually thought of that before you mentioned it, but that is very easy. Linux already has a system called that is exactly where you throw this kind of thing. It's called PRCTL. And that's where you do things like switch PowerPC endian modes and other sort of process attributes. So there will be a PRCTL set memory ordering mode or something like that, which is going to be exclusive to ARM64 and initially only supported on these M1 Macs. And then, yeah. Software can just use it. I don't know when I'll get around to writing that in, but I mean, it's a very simple thing to implement. So, either when I remember or when someone asks for it, or it's something that can be done at any point, basically. Now, moving on from the core kernel stuff. Once we have the bare minimum drivers to get Linux and USB, after that come sort of the core headless drivers, I call them. Basically the SSD and Ethernet on the Mac Mini, because obviously you want to be able to boot Linux without an external USB drive hosting all the file system stuff, and there's a nice little Ethernet port here, unless that is troublesome for some reason and I decide that I want to keep using USB for the time being. That's going to be one of the first things that I want to try to get working, because it's just convenient to be able to use the Ethernet. So once those drivers are in, and once the CPUs work properly, that's the other thing. Multi-core, obviously. Normally you boot on one core and then need to spin up the other core. So there's going to be some scaffolding to get that to work. And possibly some stuff for getting the cores to full performance level if they're not there by default. But basically, once I can bring up the cores, have Linux be able to schedule things on the cores, interprocessor interrupts need to work for this to all work properly, then you will have a headless plus crappy graphics Mac Mini Linux machine that you can use for compiling things or as a server or something like that. And that should be basically all that the people interested in that use case need at this point. So this would be a good point for starting working on some level of making this easy to install for end users. Probably not, a polished installer or anything, but at least an Arch Linux ARM image that is pre-configured and a script to install it or something like that would make sense at this point, so that anyone who just wants to have, hey, my Mac Mini, my M1 Mac Mini boots Linux, can just do it. Richard Zach asks, any thoughts on getting Linux to read APFS file systems? I mentioned earlier that there is already a driver that Corellium wrote. I don't know how good it is, but there's a lot of code in there, so I will be trying it and finding out if we can use it. Other than that, though, I don't personally intend to prioritize APFS unless I really need to. But if that code is already working well, then that's great. But I mean, if I run out of other things to do, I would look at that. Otherwise, I would expect other people to be interested in that particular challenge too. So that should be fun. Like, I'm not interested in like running Linux on APFS, but having APFS support is useful because the bootloader, as I understand it, all stores, like all the bootloader config stuff is stored on APFS. Like basically these Macs just run APFS for everything. So there are some things that if you wanted to edit them from Linux, you would have to be able to speak APFS. But it's not critical initially because you can just configure things from macOS, and you do need at least to boot macOS in recovery mode, and recovery mode will probably always be available. Like we'll leave the macOS recovery environment because you would basically like from a practical point of view, you should consider the macOS recovery environment as the moral equivalent of the UEFI setup program on a PC. These things can't do anything without, like, you can't control them to do anything without having that installed at some point, because the only way to install software on these machines when the SSD is completely wiped is via DFU mode, and all of that is signed. So you can recover one of these machines. You can never brick them by deleting stuff, which is very nice, but you need another Mac running macOS to recover them, at least now, though there is a tool called iDevice Restore that runs on Linux that I expect will gain support for these Macs. So eventually you will be able to restore macOS onto these machines from Linux, from another random Linux machine. But that doesn't let you change anything. It's just restoring a signed image from Apple. So at that point, you need to use the recovery partition to change the security settings and to do whatever you want to install Linux. So you should consider that recovery environment effectively, the BIOS of this thing, the setup menu, whatever you want to call it, and always leave it around. So if you install Linux, it's probably going to involve resizing the APFS container volume to be, tiny, maybe deleting macOS if you really don't want it, leaving the recovery stuff, and then creating, an ext4 partition on the EFI GPT partition table. So moving on that. Let's see. So after those core drivers, Ria asks, do you expect major difficulty with non-GPU peripherals, since peripheral support in Linux is fairly shaky even in x86 Macs? Well, I mean, the main thing is that, like, on x86 Macs, people expect that an x86 machine has standard everything, and so when you put Linux on an x86 Mac and it doesn't have standard everything, then a lot of things break. But the expectations aren't, for anything to be standard here. So I'm already going to be, patching or writing any drivers that I need to do, right? So like on x86 Macs with a T2, there was an issue with the SSD, and it was just a dumb, the NVMe driver needed a couple quirks. But it took forever because it took forever for someone who could find that problem and reverse engineer it and fix it and patch the driver properly to get around to doing it. So it wasn't a case of it being difficult by definition. It was just a case of it being difficult to find someone to go do it. But I'm signing up to do this whole thing full time. So things like that should not be a big deal. More interesting than that is things like if we things like Wi-Fi, like if anything is a completely unsupported, especially third-party core or something like that, that could be annoying. So we'll see what happens if there's anything that that is like sort of its own little adventure that is too big to be worth jumping into initially. But I don't expect it to be that bad. Because almost anything, for example, it's going to be horrible to support any Broadcom chips, but pretty much every Broadcom chip that Apple uses is already supported on Linux for some other reason. So although possibly not well, usually because those Broadcom chips are full of bugs. And the Linux driver often doesn't have the right workarounds for those bugs because Broadcom is a terrible company and they can't design anything. But yeah, so moving on. Let's talk about power management. Ria also asks, do you expect any difficulty around power management of these systems? So power management is a huge topic. Not as big as GPU, but potentially very big. And the main issue is getting it all to work well, especially things like sleep modes and low power modes. And it all depends on how the hardware is designed. For example, if they have sort of helper cores doing power management where you just talk to them, and I know that M1 has a bunch of little tiny CPUs around main CPU, and I believe the bootloader loads firmware for, so we don't have to worry about that. But the power management, is a big one. So initially, what you want is to just be able to turn everything up to 100%, so you can run the Mac Mini, which at least, is, runs off mains at full speed and get all the performance out of it. But then once we move on to laptops is when you really need to have a good power management for good battery life. And that's a whole different ordeal. And so it's already a somewhat open question whether I want to start working significantly in power management before or after the GPU work, or possibly in parallel. Those are two fairly big things that both need to happen at some point. So, moving on. Yichao Yu asks, I understand that supporting the full GPU can be difficult, compiler power management and such. However, how difficult would it be to have basic display support? As I said, we already get a dumb frame buffer from the bootloader, so there will be some display very soon. However, obviously we want to be able to do things like hot plug devices, like display devices, and change resolution modes. And for the GPU to work, there has to be at least some integration with like VSync and stuff like that. So the thing is, that's not the GPU. That's the display controller. What we, from the PC world talk about when we say GPU isn't a GPU. It's a chip that has a GPU. It has a bunch of video decode accelerators. It has video encode accelerators. It has a bunch of security stuff. It has some power management controllers and fan controllers, and it has a display controller. And the only reason why we think of that as part of the GPU is because, well, in the days of VRAM, the idea was that GPU takes things, renders them into VRAM, and then display controller takes the frame buffer from VRAM and spits it out to the screen. And so those things are on the same card and on the same chip. But they're different things. And so from the point of view of the M1, the display controller is as related, I expect, from the point of view of socks like the M1, the display controller is as related to the GPU as it is to like the USB ports. It's literally a different device with different drivers. The driver might be the same kernel module for practical reasons, but effectively it's a whole different code base. And so that's a different project that will happen before the GPU support most likely, which is getting at least some decent display driver, basically what Linux is kernel mode switching driver for things like being able to use external displays and changing resolutions. There is a bunch of details that go into that, but thankfully Linux has a lot of common code that we will be reusing, because a lot of this is very similar between different the things you need to do are very similar between different drivers. This is one of the main things that is different between Linux and other OSs. On pretty much every OS using proprietary graphics drivers, the GPU company gives you a driver, and that driver is a giant stack of software. It's not a driver, it's a bunch of drivers, it's a bunch of user space code, it's a shader compiler, it's a giant blob of things, right? And it's all done from scratch. On Linux, there is common code that is going to be reused. So the kernel has code for things like doing DisplayPort training and handling like DisplayPort like status bytes and stuff with the DisplayPort control channel. It's got things for doing dealing with EDID data from displays. It's got stuff for HDMI info frames. It's got abstractions around the concepts of like output pins, output connectors, display format encoders. And like all of this is scaffolding that already exists on Linux. So you just reuse that and it saves a lot of time versus writing, literally a driver from scratch. Now, Yichao Yu also says, I've read somewhere that the internal SSD might be non-true. That was the story with the Intel MacBooks. And again, that was just a stupid quirk because Apple did something weird with their NVMe implementation. But it wasn't anything hard. It was just not standard. Okay. So after basic drivers, USB, SSD, and Ethernet is when we need to start looking at critical desktop and laptop drivers. So this is the stuff that you need in order to be able to use an M1 Mac as a desktop machine without pulling your hair out too much. So audio is useful. Wi-Fi is also something that needs some work. And then some people mentioned the touch bar, and the thing about the touch bar is that if you don't support it, this thing has no function keys without the touch bar. So at the very least, there's going to have to be something so that we can use the damn thing as function keys, because otherwise, no one who wants Linux on a MacBook Pro is going to want to use it without function keys. So that doesn't mean, Mac-like touch bar implementation where we have a whole ecosystem and ways for apps to use it, but there has to be at least, some way of putting pixels on it, some way of seeing where you touch, and a daemon that can turn that into input button presses. That shouldn't be that hard. But I have no idea how the touch bar is implemented on these Macs, so that's going to be interesting. And also the camera. But I think that's probably just USB, UVC, maybe, not sure. If it's going straight to the SOC, then it might be quite a bit more interesting. So we shall see how the camera is done on these things. Actually, I could probably find out if it shows up under USB ports on here. Because I think they never updated it sounds like, actually, no, there's no USB device on the port, so maybe it isn't USB. Camera. But it has a vendor ID. It has a vendor ID and a product ID that kind of sound like USB, so maybe this system info thing is cheating and not actually showing the camera in the device tree, even though it is in the device tree. We shall see, though. Good Francois asks, touch bar has been on T2 Max for a while now. Well, I was going to talk about this later because that's another question, but let's talk about it now. Because someone also mentioned, and I will find this. Where was this thing? Yes. Marco Burato asks. No, wait, that wasn't that it. Who asks about the T2? Oh, wait, is this the one that I forgot to copy and paste? Yes, sorry. There was a question from someone who was not going to be able to attend the live, and give me just 1 second to find it. But basically, they were asking if any of the things that I work on will be useful for the Touch Bar Max. And unfortunately, most of it won't be. And the reason for that, if I can find the post. This one. Just make sure I cover everything, everyone who asks questions. Did I actually copy that? Oh, I did. Sorry. Yeah, I just can't read because it wasn't T2, it was Intel MVPs. So Antan asks, I won't be able to join, but I got a question. Will your work, especially peripheral drivers, also possibly help Linux work on recent Intel MVPs? And for the most part, no. The reason for that is that those Intel MacBook Pros are kind of a Frankenstein abomination. You see, Apple didn't replace Intel with Apple Silicon. What Apple actually did is they added Apple Silicon. The T2 Macs have Apple Silicon and Intel. And the Apple Silicon is what we call the T2. And then the M1 Max just removed the Intel. And so all that was left was Apple Silicon. Functionally, like architecturally, that's how that went down. And so, of course, the difference is that the M1 has a powerful CPU and GPU, and the T2 doesn't. But what ends up happening is that those T2 Macs have a bunch of hardware around the T2 that is connected to the T2. And then the T2 communicates with the Intel. And so the T2 runs its own OS and has its own drivers. And then the Intel communicates with the T2 with a different protocol that basically is like a network kind of thing to access these devices. And so the Intel has sort of dummy drivers that just, speak this network protocol. And the T2 runs a software called BridgeOS. And so on the M1 Macs, well, Apple took macOS and, stuck it where BridgeOS used to be. But now that's running on the real bare metal. So the drivers for all these things that hang off of the T2 on Intel Macs have nothing to do with the drivers for all those things on Linux on the M1, because it's a completely different thing. One is a network protocol and one is bare metal hardware. That said, for example, if we end up with an ecosystem for using the touch bar, then all the front-end parts of that will be useful on T2 Macs as well. It's just the driver will have to be different. Not everything is off the T2 though, so like it was a bit of a some peripherals got shuffled around. So if there's anything around there that was previously connected to the Intel, then that will still be useful. Unless your work is being used to boot on the T2 to replace BridgeOS, right? Yeah, the T2 has a vulnerable boot ROM, so certainly if someone wants to run Linux on the T2 for some reason, then any drivers that are compatible with the older hardware should work fine. I'm focusing on the M1, but I expect this work to be useful for anyone wanting to run Linux on iPhones and the T2 and anything else. I'm not going to focus on those chips, but of course I expect people who are interested in that to be to be taking that code and adding support for any hardware variants that those chips use. So moving on so we've covered sort of the useful drivers, right? Audio, Wi-Fi, touch bar, and the camera. And so at that point you'd be able to use a M1 laptop as a laptop, possibly with terrible power management, but at least you'd be able to use it with a charging cable plugged in, or at least it should last at least given the amount of power that's used, at least I hope it'll last a couple hours. Just not like days like it seems to do when you run macOS. And then at that point, the two big things are GPU and power management. So let's go through the things that we might follow with after that. Thomas Gall asks, after successful booting and GPU support, well, let's say before GPU support, do you intend to implement support for other parts of the hardware? Wi-Fi, microphones, camera, fingerprint reader, touch bar, sensors, neural engine, which would be the priorities? So I already mentioned that the priorities are going to be camera, Wi-Fi, microphones as part of the audio. As for fingerprint and touch bar, Marco Barato also asks, what do you plan to support? I would imagine SCP, touch bar, and touch ID are not in scope since they're not really needed. So basically, as far as the SCP and and I already mentioned that we need the touch bar for the MacBook Pro to be a useful machine. The SCP isn't really required for anything. We can basically just ignore it. However, it is useful. Touch ID is also connected to the SCP, so without SCP support, there's no Touch ID, and I don't think we're ever going to be able to get things like raw fingerprint images off of Touch ID, because I believe all of that is, abstracted out by the SCP on purpose. But we could implement an authentication provider, for example, like a PAM thing that uses Touch ID to log you into Linux. That should be doable. Also, as I understand it, the SCP supports things like U2F authentication. It's like an embedded YubiKey, effectively. I don't know how much it supports in the name of raw crypto providers, but if it has any sort of bare crypto support like that, then it could become a hardware-backed SSH key holder, for example. So even though none of this is a priority, it's useful, and I'll probably investigate that at some point. Not sure when, but I'm certainly interested in all the crypto stuff. Other than that, sensors, neural engine, what would be the priorities? The neural engine is not a priority for me, because I think that is niche enough and you need apps to be able to use it anyway, that most Linux users aren't going to care. But it's something that is interesting, once sort of all the other, this is already a nice Linux desktop machine, once all of that is done, then Neural Engine is certainly a fun project to look at. However, if anyone else is interested in that, then sure, go for it. Sensors, temperature, two-tone stuff, that should be pretty easy, hopefully, to do. Not sure how that works together with modern desktop environments. I'm not sure if Linux has any scaffolding for things like tweaking brightness based on brightness, but I hope someone has already looked at that because we have devices that do that. So getting the actual sensor data into Linux is pretty easy, but then you need some kind of daemon to actually use it, right? But yeah, anything like sensors are usually very simple things to work. So it might even be useful to just sort of do that as a it might be a useful newbie project if someone wants to look at that, or it's just useful as a sort of filling in the gaps and trying out basic drivers early on, just because it's easy to write drivers for sensors usually, and it lets you test things like I2C ports or whatever. So, Thomas Gall asks, do you think it would be possible to use external GPU enclosures or external PCIe? If I understand correctly, macOS, they don't work because Apple does not include the drivers included in the Intel version, or do you think there are some hardware limitations that prevent their usage? I would be very surprised if there is a hardware limitation that stops you from using eGPUs because, well, it would stop you from using other Thunderbolt devices too. And, I mean, I assume they support other Thunderbolt devices, right? So there might be some IOMMU stuff that is problematic, but honestly, I think it's just a driver thing. So unless that there's really some weird corner case showstopper, I think Linux GPU drivers should just work once they have the PCIe link up and the IOMMU is working. We shall see though. Finally, well, not finally, but next, we have the GPU. So this is basically, and again, this is sort of like a timeline, but it's not strictly, one thing is done, we work on the next thing. It's more of a rough idea of, what things to start working on in what order. But all of this depends also on like who is interested in working on other things. So for example, someone might be looking at GPU shaders on macOS while I'm doing bare metal bring up, and that's fine if someone wants to do that, right? This is just sort of the order in which I would work on things myself. But Martin Krastev asks, at what stage do you believe reversing the GPU ISA should begin? Once the kernel is booting, in parallel with that, in advance? Well, if I'm doing it, then probably once all the simple drivers are done and it's reasonable enough. However, if someone else is doing it, yeah, by all means, whenever you want. There's nothing stopping you from doing it first. Do you expect to have your GPU-rated kernel decisions influenced by the native macOS buffer management, or do you expect a from-scratch DRM approach? Definitely the second. I'm not porting a macOS driver, first of all, because that would be a derivative work of the macOS code and thus be a copyright violation. But also, I'm not interested in providing the macOS graphics stack on Linux. I'm interested in providing a driver for the Linux graphics stack, which already has a bunch of scaffolding that we can use. So it's definitely going to be understanding the hardware and then writing the, cleanest, most, integrated with the existing ecosystem driver that I can write. There's no, if you look at GPU drivers, there's basically two kinds. There's the reverse engineered drivers written by the community, which are like this. And then there's vendor drivers, which at best, like the AMD drivers, are open source and supported, but then they try to share code with their Windows versions, which happened with DC, and you end up with a giant pile of garbage in the kernel that the kernel developers fight and eventually accept because they realize that if they don't let AMD put their driver in Linux, then it's not going to happen. But yeah, some parts of the AMD open source kernel driver are really hideous at best. And then there's stuff like NVIDIA, which just use blobs and share code with Windows, and it has nothing to do with Linux, and it's 5 to 10 years late to implementing any nice Linux features. So yeah, no, definitely not any of that. It's going to be as well integrated with the existing Linux drivers ecosystem as I can make it. Matthias Gredo asks, will there be support for Wayland in the GPU driver? Yeah. Honestly, what compositor or graphic environment you use is kind of irrelevant. Effectively, Linux drivers are now implement it by having kernel code do kernel mode setting, and then you use submit commands to be processed on the GPU, and having a user space, OpenGL, and Vulkan stack or whatever that then can use that. And Wayland and X are just applications that use the GPU, and you can write your own application that uses the GPU without running on X or Wayland. I have. And so X has a mode setting driver, and Wayland just uses, this is how Wayland works. So yeah, I mean, as long as the right GPU extensions are supported to make this all work, it should be indifferent whether you use Wayland or X. I personally don't use Wayland yet, mostly because I have too much legacy stuff that only supports X on my main machine, and Wayland isn't a good idea yet. I'll probably try it again. I was waiting for KDE to get middle-click paste support on Wayland, because I can't live without that. But I think they finally got it, so I should try Wayland again on like one of my side Macs running Arch, and see how that goes. And yeah, I'll try it on the M1s once we get there. But yeah, so about the GPU, I guess we should cover a little bit about what's involved in that. I already mentioned the display controller, which is not technically part of the GPU. And then the way GPU driver stacks work is basically the kernel driver is in charge of two things: buffer management and submitting commands. So memory management is kind of related to buffer management. So this is a unified memory system, which by the way is not a problem. And the idea is that you just have memory that is allocated usually through the graphics driver so that it can handle whatever peculiarities you need for the GPU. And then it's in RAM somewhere, and it gets mapped into the address space of the CPU, and it gets mapped into the address space of the GPU, and then both can use it. All of the management, I believe, is basically already implemented in Linux, so the only thing that needs to be done is hooking that up to the MMU or whatever the M1 graphics system uses to keep track of these buffers. But that's mostly common code in Linux already. And then the main thing for the GPU in the kernel side, besides the display controller, which I mentioned is separate, is submitting commands. Now, how complicated that works kind of boils down to whether there's weirdness in the way the chip works, but also security. Because the kernel has to be secure against malicious user space trying to, corrupt other GPU contexts or even the kernel itself and things like that. And depending on how poorly designed the GPU is, that might require command validation. I highly doubt Apple screwed that up. So hopefully the GPU side of the kernel driver shouldn't actually be that much code. I think we would be talking the order of a few thousand lines of code, something like that. It depends on kind of how many separate engines and sort of separate things have to be dealt with in kernel code. Like on Radeons, you have a bunch of different engines, like a memory copy engine and the actual graphics processing engine, and then there's other stuff for like video decode. I don't know how it works on the M1 GPU on the AGX Apple graphics. But it's mostly about that, about how many things you have to do, but not about the details of what the processing is gonna. The processing that is going to happen in these engines, because that's up to user space. The kernel just has to take the commands from user space, make sure they don't do anything evil, which hopefully is not something we actually have to do here, and send them to the hardware. It's basically going to be a ring buffer with some pointers. And also, there's a few other things. So you things like fencing and so that you can I'll explain this, so that you can order things in time so that something runs after something else is finished running and that kind of thing, right? There's synchronization involved, so that's also part of this. And then that ties in with the display controller to be able to do things like flip the buffers once you have a new frame ready. But yeah, all of this is fairly small compared to the user space side. The user space side is where it gets interesting, because the user space side is in charge of taking whatever API the app is using, whether Vulkan or OpenGL or OpenGL ES or something else potentially. There's some DirectX support too. And converting it into commands that the GPU can use to actually render on the, on whatever architecture it has. And that involves also compiling shaders. So that involves reverse engineering the shader ISA and the command stream, and what kinds of, basically you need to map all of these features of whatever layer of the software you're targeting, which could be definitely not going to be OpenGL at the top layer, because that's all, that's horrible if you have to write an OpenGL driver from scratch, but that's all, already abstracted out for us in the open source drivers. So we'd be talking about either Vulkan or Gallium 3D. And then you need a shader compiler to go along with that, so you can actually compile shaders for the hardware. And yeah, that's, it's definitely the biggest part of the project. We will see how big it is and how hard it is to, for example, get the first triangle on the screen. We do have some hints, because the Apple graphics we know how the architecture works from public presentations and from the fact that it's a descendant of PowerVR graphics. And we know there's definitely some PowerVR tech in there, because as far as I know, Apple is still paying PowerVR royalties. So that suggests that they're at least still using some of PowerVR's patents. And we do have open source PowerVR graphics drivers for the kernel. They are horrible. You would never want to use any of that code whatsoever. Also, most of it is redundant and crap and useless. But if any of the hardware that is interfacing with still has similarities with the AGX, then using that code as a hardware reference would be useful. I do believe the shader ISA is completely different. It's not PowerVR. So that's going to be a from scratch reverse engineering project. And all of that is going to be done basically by running stuff on macOS. So the way you do reverse engineering for graphics drivers efficiently is, for example, if you're doing shaders, then you compile some shader and then look at the binary and see what it got compiled to. It's very likely that there are, documented or not, tools in macOS or Xcode already that'll, at least disassemble shaders for you or have some hint of what the instruction set is. So I've done blind ISA reverse engineering in the past. I can do it, but I would be surprised if I have to do that, because usually if you write a shader compiler for an OS, there's going to be a disassembler somewhere in the code base, or something at least, providing a list of instruction mnemonics or something like that. There's still going to be a lot of understanding the architecture, right? Because we have no idea what it's like. This is not like a CPU. Shader architectures can be extremely varied. There can be pipeline issues. There can be, all kinds of threading related things, multiple kinds of SIMD, whatever. So it's definitely going to be a big project, even if you have this assembler understanding what the instructions are doing. But it shouldn't be, a black box, figure out what the instruction bits do project, hopefully. So that's the shader side. And then, of course, that gets implemented somewhere in the Linux graphics stack. There's no point in reverse engineering Apple's shader compiler. And that would be sort of potentially legally problematic anyway. So once you know what the ISA is doing, then you just implement that in an existing compiler. Now, the other story is the command processing, the going from APIs to hardware commands, hardware draw commands. And the way you reverse engineer that is the same way Nuvo does it, basically, which is that you run Apple's driver in user space and you intercept its communications with the kernel and dump the command buffers, and then you just try things and see what the command buffers contain and figure it out that way. And this is both basically legally clear. It's pretty close to clean room reverse engineering in its result. But also, honestly, it's just no fun reading graphics driver code, and most of it is redundant. Like, I don't care how Apple maps from, especially Metal, because they use Metal, to their hardware. I care about what the hardware does, and then I'll figure out how to map from the Linux driver stack to that hardware. So the important part is understanding what the hardware features are, and then implementing support for that in the existing open source stacks. And that's ideally much faster than trying to understand what Apple's code is actually doing. That said, that's the user space side. But for the kernel side, it's entirely likely that it will be useful to just decompile or disassemble Apple's drivers, because it's just like kernel drivers have a much, like, if you look at the user space side, it's a processing black box, right? But user space drivers, we call all these things drivers. So drivers do lots of different things. Most of the kernel drivers in a system are basically adaptation layers, right? They're turning a common or perhaps proprietary but still different interface that the user space uses and adapting it to an interface that the hardware uses. But this adaptation is usually a very thin thing. So you're doing things like moving commands around, but there are few algorithms in a kernel driver. You're mostly just moving buffers of data around or configuring modes and things like that. However, if you look at like a user space graphics stack, there's a huge amount of algorithms because you got things like OpenGL state trackers. You're gonna have things like texture formats. You're gonna have the whole compiler thing. Optimization. Optimizing compilers, a giant piece of code, all that stuff. So for giant blobs like that, it's more useful to see what the inputs and the outputs are, and then write your own blob. But for hardware drivers, the outputs, the interface to the hardware tends to be potentially very opaque. So I very much enjoy doing black box hardware reverse engineering, and that's especially useful for figuring out like the final details once you understand some of the hardware to be able to write a nice documentation for it. But nobody reverse engineers hardware by trying to flip register bits and seeing what they do from the start, right? So at that point, you need to, at the very least, see what the Apple drivers are doing, like intercept their hardware calls. But it tends to be easier to just decompile them and see what they're doing. And then, of course, you're not copying the driver. You're using that as a tool to write a spec, whether literally a file or in your head, to understand the hardware. And then you ignore whatever Apple was doing and do whatever you think makes the most sense to make a Linux driver. So I think that basically covers the GPU part of things. And by the way, I am absolutely not a GPU expert. My experience with open source GPU development is basically Radeon kernel drivers, which I did on the PS4. And so I know what to expect on the kernel side, but I've never messed with the user space side. So this is going to, it's going to be a big learning experience. But again, these projects always are full of learning experiences, so that part isn't new to me. Whoa, let's move on a little bit. Lucas F. writes, which functionalities might likely remain unsupported due to lack of documentation? Well, due to lack of documentation, nothing, because we don't have documentation for anything. So we're already starting from the premise that lack of documentation is not a reason not to support something. That said, it's more of a question of what is interesting or what the priorities are. In principle, there is no end date. There is no, the project is done, shut down the Patreon date. Rather, this is an ongoing effort of, improving support, maintaining it, and then adding support for new devices as they come on. So I expect people to support me as long as they feel comfortable supporting the idea of someone working full-time on writing and keeping and maintaining Linux on the Apple M1 series and whatever comes after that, M1X, M2, whatever they call it. But the question is more of along the lines of what will we get to, what will we not get to, what is likely to end up on the back burner indefinitely. And to some extent, that depends on how much people care about it. Because if enough users care about something, it's likely to get done. But personally, I guess, for example, like if I have my work cut out for me with the GPU, I might not look at Touch ID for a while. Let me just look at this thing, and I can there's not that many ports on this thing, is there? So there's not actually that much hardware that we can talk about. It's just like, well, nobody cares about that. Some details. I don't know. It's kind of hard to say. Like, there's always going to be little corners of non-supported features or things that don't quite work well. But it's hard to say, like, a priori what those are going to be, and it ends up depending on what people want to be done, right? So there's nothing that we can't support. It's just time will tell kind of what we want, what we want to support. But my goal is everything, right? Within the amount of time that I have in the day. People keep asking about whether like Apple can kill all of this. Well, yes. They are letting us in, and they can choose to update their firmware to not let us in. And the question is, are they going to do that? And I don't think so, because, if they they enabled this functionality on purpose. That means they have some reason to have it. And also, technically, the only way to truly stop us from running Linux on the M1 would have to go through stopping people from running unsigned kernel extensions on macOS. Because even if they disable this functionality to run a custom kernel, you can always just write kexec.kext, which is what we did on the PS4. And if Apple does that, it's going to piss off a lot of driver developers. So there are multiple levels on which I don't think this is going to happen. Also, this also falls into consumer protection laws. Sony got sued for removing Linux from the PS3 and lost. I would expect Apple to get sued if they try to remove this feature from the M1s and lose, because it truly is removing features from hardware that customers purchased that had those features, which is actually not something that is, legal in most places. No, they didn't kill off Kext. They killed off Kexts if you don't disable any of the security. So they still have a backdoor for putting in Kexts, and it's along the same lines as the whole Linux thing. So no, Kexts are not gone. It's just that Apple doesn't want people writing Kexts and shipping drivers that require Kexts, and they wanted to use all the new frameworks. But the Kexts are gone. It's just working in a different way. Before I move on, let me look at the chat a little bit, because I only have sort of general questions and some final stuff, and then we have a bit more of a chat. But I'm going to do a quick skim over the chat and see if I see anything interesting. Let me go just back. That'd be interesting. Big Little, MMUs, Needle Driver. Old link that working, GPU stuff, political challenges. How do I plan getting Linux to work with the power efficient high performance cores? Linux already supports that. Big Little. Android does that, as multiple people have said. The docs for AMD chips are public, and the open source started for those. The docs for AMD chips are not public. Some docs for AMD chips are public. Not all of them. Just like some docs for Intel chips are public, not all of them. The only fairly comprehensive documentation we have of AMD and Intel GPUs are the actual drivers. They've released some docs, but you couldn't write an AMD GPU driver from just the released docs and not the kernel code. Not even close. GitHub repo, that was mentioned at the beginning. Asahi Linux. Lisp controllers. No, the M1 does not have any x86 instructions embedded into it. It does have some memory ordering support for making x86 emulation more efficient, and it has some instructions which are intended for x86 emulation, which are just part of ARM's instruction set, because ARM is not stupid, and they have already been thinking about this. So more recent additions to the ARM64 instruction set already have things which don't say x86 in the name, but are very much, we put this instruction in here so we could emulate x86 without, sucking. Do you expect that Apple will use standard controllers for some of the more necessary peripherals, like a design or PCI controller? Actually, yes, we have some of that stuff. I believe they have at least designware USB for the gadget mode, which is probably what I'll use for to load Linux. I think I already have some horrible like user space designware code I can probably copy and paste into Mini and use for that. But yeah, I like the M1 is Apple Silicon, but it's not 100% Apple design, and it wouldn't make any sense for it to be 100% Apple design. We know Apple did the GPU. We know Apple did the CPU, and we know Apple has been doing a lot of the scaffolding and definitely, the general architecture. But Apple didn't design, the USB controller. No way. There's no reason for them to do that. You can just buy that, right? They're not going to get anything out of doing it themselves. So, or SD cards or anything like that. Do these things have SD card slots? They don't, right? No, they don't. Maybe the iMacs will. We'll see how they do that. Hope it's not another Broadcom chip. But yeah, so some of the and some of the chips are also semi-standard, right? Like outside the M1, the stuff on the motherboard. So we should be able to reuse code for that. Internal audio, macOS, emulation drivers. Jake Fossen asks, did Windows implement their own driver to get function keys? No. On T2 Macs, the touch bar by default is in a mode where the T2 is putting up the function keys, and emulates a keyboard. But again, the T2 isn't the thing on M1 Max. We are the T2. So we don't get that, I'm pretty sure. I'd be highly surprised if like the touch bar is running on the SEP or something now. I'm very curious as to actually how the touch bar is driven. Because again, on the T2 Max, it was a virtual USB device with some commands to send images to the touch bar and get stuff. But obviously here it's going to be bare metal. Is it a display? Like, is it a separate head on the display controller? Or is it a completely different controller? What about the actual touch sensor? Like, I have no idea what they did, so that's going to be interesting to find out about. Bootcamp drivers, TSO, Touch Bar Max. Did they just not? Ridley asks, yeah, the Touch Bar protocol has been reverse engineered. I don't know if anyone actually did anything useful with it. I know that people showed off, like, putting images on it and stuff. So I just don't know if it's been productionized, so to speak. BridgeOS, blah, 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 Touch ID. GNOME can use brightness based off a light sensor already. I'm a KDE user. But yeah, sure, if you can do that, that works. eGPU, PCI V8 space, yeah. I would expect ARM to have fixed this. It'd be pretty dumb if they had like PCIe address space limitations that are breaking eGPUs, and that's the only thing. Like, it's just, that sounds like the thing you would fix for the M1, right? Like, why wouldn't you? It's pretty sad if they don't. But yes, you need a lot of bar space for the VRAM indeed. I've seen that issue before. Funky knobs. Yeah, for those who don't know, one of the reasons the Radeon driver didn't work on the PS4 originally was because they messed up knob support in one of their firmwares. That was great. RVR and LVM binaries for the GPU ISA. Yeah, I mean, you can definitely pull instruction set info from the LLVM binary, like at the data level. But I hope we don't have to go there. There should be ideally already command line tools we can run to disassemble something, or at worst libraries we can import and call functions on to disassemble stuff. I'm going to be pretty surprised if literally the only way of getting information on the instruction set for these shaders is the LLVM part. I mean, again, you have to debug these things, right? I think even NVIDIA gives you like shader decompilers, so disassemblers at least. And then neural engine support, some neural engine support. Richard Sagas, yeah. So it depends on what the hardware is doing. Honestly, like, I have no idea how they implemented that. If it's a GPU-like thing with a command buffer, then it wouldn't be too hard. Also, by the way, you can write user space drivers for hardware, especially if you don't need interrupts. You can just do it. And usually for most hardware, you can just ignore interrupts and poll. So like you can write mock, like prototype drivers in user space for most hardware. I mean, completely insecure, of course. You have to map all memory, but to get the IO registers, but you can. So it's entirely possible to, say, for example, prototype a neural engine driver in user space and then port it to the kernel once you know how it works. But yeah, I mean, I probably what I would do is I would take a very quick look at whatever driver Apple wrote for their kernel to support this, and just to get a feeling what it's doing, how that hardware looks. And then we'd have to figure out if, sort of how to move forward on that. To Sony. Torvalds has not reached out to me yet. I do not expect him to reach out to me until this is getting merged into Linux. And it's going to be very interesting if, say, some sub-maintainer is being unreasonable about accepting this code on Linux, and then like Torvalds shows up and tells him to shut up in his typical fashion or something. Or conversely, if this actually gets to the point where this is usable as a desktop thing, and then Torvalds starts using it, then I might get some patches for Torvalds to merge into my tree, because I'm going to be maintainer for this port, right? So then, if he decides to fix a bug in my code, then I might get patches from Torvalds, which would be hilarious. But yeah, we'll see. Future machines have both in-package memory and out-of-package. How complex will that be to support? So the thing is, as far as I know, the bootloader is going to set up the RAM for us, and I truly hope we don't have to deal with some of the horrible things around that. We might. It really depends on the sock vendor how they implement this. Like, for example, oh geez, I read a little bit about like how NVIDIA does this on their Tegras, and like the bootloader does RAM initialization, like on the Chromebook Pixel. It's literally the only closed source part of the entire Chromebook Pixel is a blob that just does RAM in it, and it's like the NVIDIA. Like Google couldn't get NVIDIA to open source it, and so they package it as a binary file that the bootloader, like U-boot, puts into memory and jumps to, and it sets up the RAM, and it basically upclocks the RAM. Like before that runs, the RAM is at minimum speed with hard-coded timings, and then that like upclocks it to the maximum speed. But then the kernel needs to be able to change speeds, and then there's this whole mess of very redundant code with that in the kernel to do that. The saner way of doing this is to have a separate CPU dealing with the power management for RAM. I know Apple have a bunch of separate side cores, and I do believe the bootloader loads firmware for them. So I hope at least the bootloader puts the RAM into max performance mode for us to boot. So at least we get max perf RAM by default. And that is going to be the same whether it's external RAM or internal RAM. Now the question is going to be power management. Is that going to be done for us in another core? Do we have to have a pile of horrible PLL code in the kernel? Which is going to kind of suck if we have to do that. I will deal with it, but I'm currently hoping I don't have to do that. But I might have to. But hopefully there's not going to be that much difference. Well, yeah. Hold on a second. So you're talking about like external RAM and internal RAM, like out of package versus in package. If it's still soldered down LPDDR, then it should be the same, just different timings or whatever. If you're talking about future chips literally having SODIMM slots and supporting like DDR, not LPDDR, then it's a different memory type. And so if there's memory specific stuff that has to be supported there, like for power management, then that's going to be an issue. But then again, those machines are going to be desktops, and so we can probably just leave it always at full power. They might not even do power management on desktop RAM. I don't know. We shall see. I'm surprised they left the door open. They might close it before it's too late. Nah, they're not. They're not going to do that. Like, look, Apple PR is never going to say anything, but they already did one thing, right? They said like Windows can run on the M1s if Microsoft wants to, and they mentioned it was licensing. Obviously, they'd have to document all this or write drivers for that to happen, but they already made a public PR-ish claim that the Mac is an open platform that can run Windows in theory. So that's already something. And yeah, nah, they're not gonna. If they backtrack on this, they might backtrack on this for future chips or future devices. But I would absolutely not expect them to retroactively remove it from existing machines. We shall see what they do. But it seems, I mean, this is the fact that they left this open is already somewhat proof that they are not trying to iPhoneize the Mac ecosystem, because this is the perfect time to do that. And it's the perfect time to do that, and the impact would be the lowest because nothing runs on M1 Macs but macOS, so they could lock it down and say, well, what are you going to run on it anyway, right? But they didn't do that. And since they didn't do that, why would they do it later? It's kind of, it doesn't make a lot of sense. Yeah. Anyway. Yeah, Apple Plus say docs what you use exactly. Google results searching all about your own work. Probably very soon, especially because since I mentioned on Twitter the other day, it's like it seems the entire iPhone and iDevice jailbreaking and repair community is like deliberately avoids documenting anything because I guess secrets are cool or something. So yeah, I expect this to be hitting top Google results pretty quickly. Moving on, Synopsys USB controller. Oh yeah, it was Synopsys, right? DWC. Yeah. Take a lot from the boot log. Yeah, as I mentioned, they probably license existing PCIe IP. They might do some weird IOMU stuff. I don't know. Like IOMU sounds like the kind of thing Apple would do on their own, but for the actual controller and PHYs and all that, they probably license something. What is handled by this hardware? Oh wait, hold on. Are you talking about both in-package memory and out-of-package memory? Sorry, I just understood what you're talking about there. Really? You think they're going to do that? I wonder. I mean, Linux already does NUMA, which is part of this whole story. But yeah, I don't know. That would be an interesting question. User space API to run TSM on from macOS process. Oh yeah, for macOS. Let's see, PRC, synopsis. Oh, there's a MIPI DSI synopsis controller. Okay. Then their own USB 4 controller. I could see that. I'm curious what they did for Thunderbolt and USB 4, especially because the Intel stuff kind of sucks. So we shall see. 5K right now. iMac work. Haven't done anything yet. Might be on the back burner eventually, since I was a little bit busier than I expected in December. We shall see. It's a thing that might just happen one weekend if I get around to it. Man pages. 3. Oh yeah, by the way, this is not something that I previously mentioned on the Patreon because I didn't want people to get confused, but the whole running your own kernel thing on Apple M1 Macs isn't 100% of the way there yet. I believe for some strange reasons they ended up with, like, it was in the man pages first, and then like in the latest macOS beta, some part of it is in there, and then the next part should be coming in the next macOS beta. So I'm confident that it's going to come. It's just not quite all the way there yet. So don't worry. Like this, it's not like they're going to like suddenly not do it and backtrack and not have Linux. But if they do that, we could use the Hext trick to get Linux running anyway, because that's already there. Like there is a way to in already. It's just it doesn't make sense to use it because they're going to release an easier way. Probably, you know, in January. So yeah. And in the meantime, I'll be working on reverse engineering things and getting the serial port to work and everything, so we're not going to be wasting time. LVM4, GPU back, and running it on Tegra. Is there? Oh, yes, it is. NVIDIA is evil indeed. Yes, you can use Kali Linux on M1. You can use whatever Linux you want on M1. I'm going to work on one Linux distro that it's just going to be convenient to use on the M1, but you can use whatever distro you want. Anything that supports ARM will work if you install the right kernel and the right patches before I get around to, before everything gets upstream and trickles down. And that's the other thing, right? It's like, you know, the Asahi Linux as a Linux distribution will be bleeding edge in that sense. Yep. People already answered most of this. I expect Apple to be designing their own memory controllers. That'll be interesting, actually. I wonder if they did that. And yeah, Ridley's talking about the memory stuff now. I think it's plausible. 16 gigs of in-package memory, unified doing GPU stuff, and DIMM slots for massive amounts of RAM on the Mac Pro. It does make sense. I guess we'll find out. And yeah, is the DSI for the touch bar? I would expect yeah, that's what I was wondering too. That I would expect DSI for the touch bar and EDP for the main display is what makes the most sense to me. So I do wonder. Let's ring all the bugs. Machines breaking up, people restored. Did rush the release? Yeah, probably. Distro lockdown touch bar. Yeah, we need commands for the chat. Yeah, we're gonna have, like, you know, quick answers for everything. We're getting near the end, by the way. I only have a few questions to cover about general stuff, but yeah, like, by the way, sort of on a, like, if you look at the whole M1 release, like, everything is so great, right? Like they both threw money at the 5 nanometers. They obviously had a team who did a really good job on the design, but also all the integration, all the power management, all the, like, you know, all the pieces are so polished that they are making people think the M1 is a miracle, when what it really is just a lot of work was put into it. And I get the feeling that that also involved a lot of very overworked people at Apple, because this kind of project doesn't really happen without abusing your engineers, unfortunately, in the real world. Mikhail asks, will that distro work? It's an Arch port. Of course it's going to be systemd. What else is it going to be? Yeah. Anyway. So, final questions. And this is just sort of general stuff. Do you think the Linux port will have similar pros to the vanilla Mac, such as good battery performance per watt? That's the goal. The goal is to fix any dumb things that are killing performance per watt. Now, there are some things that are also just more worked. For example, video acceleration is one thing that I do want to implement, because at least decode is very important for being able to just watch videos without killing your battery. So I forgot to mention that in the list of things to work on, but somewhere around GPU video decode is also, like, probably after core GPU video decode would be next, because you definitely want that for like YouTube and things like that. Again, how difficult that is depends on how they implemented it. And but then, like, about the details, it really depends. Like, there's a lot of polish in Mac OS, and there's going to be probably, like, you know, cases where we don't do as well. But my goal is to not have any blatant, like, this thing doesn't have power management, or we can't get into that sleep mode, or, you know. So anything that is down to hardware support, I intend to make work. Now, if we run into things where, like, the Linux kernel doesn't have framework support for this level of power management to the extent where macOS does, that could be a reason why we have trouble catching up to macOS on that. Realistically, given sort of, you know, the amount of work involved, I would say it's reasonable to expect we're never gonna, I'm not gonna say never, but we're not gonna be as good as macOS, at least initially. Well, definitely gonna be terrible at the very beginning, right? It's definitely gonna be no power management initially, but, you know, once we get the basics down, it's probably not gonna be as good as macOS, but it should be at least decent. And that is the most pressing goal for using this as a laptop, is getting decent power management. You know, like, maybe it doesn't last forever when you have it idle and mostly, you know, just not using it, but it turned on because our idle power draw isn't as great. But at least while using it, you know, you're not using twice the power the macOS is, or something like that. There shouldn't be any horrible things eating power. That we should fix everything along those lines. But yeah, I can't say sort of we're going to be better than macOS here and there. But then again, we might be better than macOS for some things just out of software design, right? So, for example, completely hypothetical, let's say the Linux graphics stack ends up doing less work per frame under some conditions than macOS does because of design or whatever, then that could give us an advantage. I don't know. Or a disadvantage if it's doing more. And that's not a power management thing. That's a software design issue, right? So, yeah. Just kind of thoughts on that. Delroth asks, what would you consider to be the end goal for reporting effort? As in, at which point will you stop working on this full time? Is this the case I'll continue as long as people continue funding me, or do you have a milestone in mind? Well, I already mentioned, basically the latter, right? So either that or until I get bored. And by that I mean, if it gets to the point where I'm truly uninterested in the work that remains, to the point where it doesn't make sense to work on this full time, then I'd have to figure something out along the lines of either diverting money to other people who want to work on this, or, you know, stopping the Patreon or something like that. But in principle, the idea is to, you know, I don't think this is ever going to be done because of all the new devices coming out and because there's always going to be things to polish, right? So as long as I don't feel like I'm not able to contribute efficiently towards the project, then I will keep doing it as long as people support me. But I'm also not going to sort of waste people's money, right? So if I feel like I am not doing useful work, then I will figure something out so that we can move on in a way that is efficient for everyone. We already talked about the next one. Okay, Tobias Vogel asks, could you elaborate? Yeah, okay, so these are the two fun questions at the end, and I'm going to read both of them first, and then talk about that. So Tobias Vogel asks, could you elaborate on the legal situation of the port, bearing in mind that running macOS in a virtual machine on non-Apple hardware is strictly speaking still illegal? Okay, so that's a different thing, right? Running macOS in a virtual machine on Apple hardware is running macOS without a license to run macOS, and therefore a copyright violation or a contract violation, or whatever, however you want to interpret it, based on copyright and contract law. But this is Linux on a Mac device, so there is absolutely no legal problem with running Linux on a Mac. In fact, that's why they have the feature to be able to do that, and that's also why this is different from, say, running Linux on a PS4 or a PS3 or a Wii or any other closed device, because doing that requires running an exploit. And that exploit, due to unfortunate laws like the DMCA, could, under some interpretations, be considered to be a anti-circumvention violation. None of that is the case here, because this is open. It's already designed so you can run your own OS on it. So there's no legal issue with that. Now, Marco Burato asks, you mentioned that you want to reverse engineer how macOS uses the hardware, but as far as I know, to use macOS, you first need to accept the EULA, which says you may not reverse engineer, disassemble, attempt to derive the source code off, blah, blah, blah. I believe there are some exceptions by law, but where do we stand on this matter? Okay, so here's the fun one, and I was wondering if I should write a blog post about this, and I think for the time being, I'm going to leave it at story at the end of this stream, mostly because I might want to ask a lawyer before making a full blog post out of this. But to cover how I approach these things. So first of all, there's two different questions here. One is whether the actual act of reverse engineering is legal, and one is whether the result of reverse engineering is legal. The first question is mostly moot, and the reason for that is that, yes, there is an EULA that says I can't do this, and every iPhone jailbreak person is doing this, and Apple isn't suing any of them. Apple isn't going to sue me for doing this. The EULA is a civil contract, right? So it only matters insofar as Apple is willing to enforce it via their legal team, which I don't believe they would, because they wouldn't gain anything from that. Why would they care about what I'm doing here? Then the real question is, how legal is the result? And this is where we get into sort of stories about clean room reverse engineering. A lot of people, when they think about this whole reverse engineering thing, they say, oh, just clean room reverse engineering it, or there's a lot of drivers that will have said this driver was clean room reverse engineered. And if you look at the Wikipedia definition of clean room reverse engineering, it usually goes like this. You have one team of people, or one person at least, reading the binary, the decompiling or whatever. Then they write a spec, and then a second team reads the spec and writes their new code. And this is the kind of approach which you get when you have a company that is, for example, making an interoperable product with another company's product, and they are doing this adversarially. The other company doesn't want them to do this, but can't stop them from doing it if they don't break the law in some other way. And so by doing this clean room approach, basically that is a legal defense their lawyers can use it's a strong legal defense their lawyers can use if they get hit with a copyright lawsuit. Clean rooming like that is a legal defense. It's not a legal requirement. And so it's basically covering your ass for the lawyers. It makes sense when the other company is really upset that you did the reverse engineering. But it's not a legal requirement. And it's also not a legal guarantee that it's not a copyright violation. For example, if the spec contains the moral equivalent of an algorithm from the original code, then implementing that spec could still be a copyright violation. There's no bright line that guarantees that you wrote a spec and then wrote code based on the spec, therefore it's still not, it's no longer a derivative work. It's a pretty strong defense, but it's not 100%. But then, if you actually look at people who say we clean roomed this or we clean roomed that in the open source world, and a bunch of drivers in Linux are reverse engineered, many have made no claims about any of this, and some will have said clean roomed. What people actually mean is we followed a process that has an outcome that is basically the process is designed such that that outcome is in practice not a copyright violation, nobody does the one team writes the spec, the other team writes the code thing. Not 100%. Because that's just not practical, especially when you're working in smaller teams, especially if it's like a side project or an unfunded thing. What people do is try to use approaches that minimize the chances of there being a copyright violation. So this is, for example, what many GPU driver developers do with the whole tracing hardware accesses, right? The assumption is that doing the same thing the Apple doing with the hardware the same thing that the original driver is doing is not a copyright violation of the actual driver's implementation. And so that's one way, and that's one thing that I will do for places where that makes sense. But it's not always possible to do it this way nor practical. And so when you're reading binaries and reverse engineering things, what you need to do is have this whole thing very clear in your head, right? Like, you need to have a mentality that you're reading code to understand the hardware, and there you're going to write your own code that targets the same hardware, and that probably has nothing to do with the original code. And I've seen this done well, I've seen this done very poorly. I have a lot of experience doing this because I care a lot about this. And so sometimes it's very easy to do because very often the original code is just crap. You wouldn't want to use the original code anyway. In the case of Apple, for example, well, they use Metal, so that's already a really good reason why there's very little chance that even if I peeked at their user space graphics stack code, that I would be adding accidental copyright violations, because like their entire API is different, right? So it doesn't make sense for me to copy code anyway. But and for kernel drivers, again, if the driver is a thin shim, if it's really just adapting hardware to a user space API, there's very little in there that you would really copy that is not obvious because of what you're doing. Where it gets tricky is with basically two different things. One is decode, especially like decoders and encoders. Anytime you have compression or a file format with a complicated structure, or especially like audio video compression formats, that kind of stuff, especially encoders. Because while decoders are expected to basically do a similar set of things for a given format, no matter who wrote the code, there's a lot of freedom in writing encoders. So if you read some encoder source code, which could be like a compressor for a compression format, then you could very easily end up accidentally copying an implementation detail. So for those things, it makes more sense for someone to read the code, understand the format, write a spec, and then someone else to write the other code. So these are situations where targeted clean rooming is useful. I don't expect there to be many of these in this project. What I do expect, to some extent, is the other class, which is what I will call magic code, magic hardware driver code. This is usually initialization code that makes the hardware work. And the problem with this code is that it uses features of the hardware that none of the rest of the driver uses. Like during normal operation, none of these registers are toggled, none of these things are tweaked. It's just things that have to happen, or the thing doesn't work, or it doesn't work properly. But you have no idea what they mean because there's no use of these features that you can correlate with a feature, right? It's just something happens and the hardware now works. Now, my approach to this is that if it's just initializing registers, if I boil it down to literally a list of register rights, so literally write this value to this register, like an array, in my opinion, that's no longer copyrightable. And that's the same outcome you would get by tracing hardware accesses from a proprietary driver anyway. So if you can boil down an init sequence to that, and by the way, like AMD GPU on Linux has a pile of tables like this in the kernel too, like that's how AMD does things literally, then that's fine. Now, where it gets problematic is power management and especially clocking and clock gating and PLLs. And this is that blob for the NVIDIA Tegra, right? The memory setup code. When you're dealing with clock management and power management, especially clock management, anything that turns things on and off or changes their speed in hardware, the problem is if you do it wrong, it tends to just crash. So it's very difficult to understand what the registers are doing. And very often, because if you're dealing with PLLs, that's analog hardware. The spec for these kinds of devices literally ends up being pseudocode or literally C code pasted into the PDF file. Like, no joke. Like, most of vendors don't even document this, and it's like under NDA or it's just in some reference code. But if you find the rare case of an SoC datasheet that actually has like documentation on how to reclock things, chances are you're going to end up seeing a pile of source code pasted into the damn thing. It's that bad. And so here is where I don't have a good answer for this. I will deal with it if I run into this case and I'll figure something out. But ultimately, this is a problem that doesn't have a great solution. If the code is simple enough that you can understand what the hardware is doing, then you might be able to replace it. Or you might be able to boil down the logic of the code to a high enough level to at least add a layer of installation and then give that spec, which really is a pile of pseudocode, but okay, to another person to write the driver, and sort of hope that adding this level of abstraction insulates you enough from the claim that this could be a derivative work. Or you could just say, well, we're screwed. We're going to pull the original Mac OS code for this and pass it to Linux in some way so it can use it without being a copyright violation by literally pulling it from, your existing install of Mac OS. None of these solutions are ideal. And my best hope right now is that we don't have to deal with this situation, because for initialization of this kind of low-level stuff, the bootloader will have taken care of it for us. And if we're lucky, power management, like active power switching, is handled by a different core, which is a good design anyway, often. Like, for example, if you're reclocking RAM, you can't use RAM, so how are you going to keep running the OS? Like, there's a bunch of corner cases like that, right? So if we're lucky, Apple is doing this in firmware on a different CPU with an API we can just use. If we're unlucky, we need a bunch of PLL reclocking code in Linux. And all I can say right now is I'll figure out what to do about that when I see that code. But yes, if it gets to this point, that's the point where we start talking to EFF lawyers, as Ridley just said, and figuring out what the sanest way of doing this is. It's also the point where I start talking with a lot of friends who are very experienced with hardware like this, and maybe throw enough eyes at this problem and we can solve it effectively. But yes, there are some very specific corner cases. But other than that, I'm quite confident in my ability to not accidentally create copyright violations. Now, the other story is, will other people think that's not good enough? There have been I saw one Linux kernel discussion about this, but there was no real push from the original developer of the code to get it included. It was more of someone wrote this code and someone said we should merge it, and then someone said, oh, this has been decompiled. But that was a binary Linux driver that someone else reverse engineered, and so I think the assumption there, or the understanding, was that it could be a very straight recreation of the original driver, possibly a clear copyright violation, because that was already a Linux driver. That's a lot less likely if we're doing macOS drivers, and a lot of drivers on Linux have been based on reverse engineered code, and nobody has complained. I would not expect to run into showstoppers. I might get pushback when I try to upstream some of these things from some people who don't understand the whole thing I just spent the last 10 minutes talking about. But in practice, once I explain my process and how I work, I don't think anyone's going to say you didn't clean room it, so it's not getting upstreamed. At least not say that and actually have a say. among other things, because I could just CC Linus and see and be like, hey Linus, you wanted Linux on the M1, right? But yeah, like this is not something that is new to Linux, to how Linux drivers have been reverse engineered. A lot of stuff has been done like this to some extent, whether people admit to it or not. And yeah, like to some extent, the way Linux kernel contributions work is the upstream trusts that when you slap on the sign off line in the commit message saying this is GPL'd, that they trust you that it is GPL'd. So, why would they say they don't trust me? We shall see. But yeah, like realistically, there's no way for me to improve on this because we are absolutely not doing the 100% kosher clean room thing, because that would just make everything, we would require 4 times the amount of people and effort and everything for no reason. So that's not viable, basically. And it's not viable for any kind of small team reverse engineering model. What you do is you follow processes that are efficient, that keep things close to that, but you can't guarantee the textbook Wikipedia clean room definition in this kind of project. It's just not a thing. And most of the time when people say this is clean room, they do not mean this is Wikipedia textbook clean room. They just mean effectively we think this is equivalent, which is what I do. What I do is basically clean room in my head, right? Is my entire approach to this. But yeah, what I can say is I care about this, so hopefully you can trust me that I know what I'm doing here. And yeah, I think that's basically the end of the questions that I got on Patreon. We've gone through 2 hours, a nice 2 hours round, but I still have some time to take any questions from people who are watching. We still have 260 people watching. Nice. And about anything, by the way, about the project or even personal questions, which I reserve the right not to answer, but you can try asking them. So, or about anything else that I've done, or about past projects, or anything really. Ridley says, Small Brain, Oracle arguing that APIs are copyrightable, Galaxy Brain, Apple arguing that hardware interfaces are copyrightable. Yeah, that's the thing, is Apple is not going to actually. That's the other thing, right? They're not going to sue anyone for this. Heck, I'd be more worried about Imagination Technologies being stupid about the GPU stuff that they claim they still own IP on than Apple. Apple isn't in it. They haven't sued jailbreakers. Like, how on earth would they sue me for this if they haven't sued jailbreakers and like the iPhone Linux people and all that stuff? Shiz mentions, personal question, how was your weekend? My weekend was okay, I guess. I don't know, like today was mostly planning for this a little bit and cleaning up my room so that it wasn't a giant pile of boxes behind here. Like now it looks like, now that stuff in the back looks like at least there's some logic to it, but before it was a lot worse. And yes, VLC hat indeed. Nope, this year no come back to Spain because, pandemic. Yeah. Someone asks, what if Apple offers me a job? I probably wouldn't take it if it's a full-time job. Because I've done the full-time at a company thing, and I've decided that's not for me. But which is why I'm very excited to work full-time on this, because when I say full-time, I don't mean like 9-to-5 job. I mean, devoting an equivalent amount of time, but obviously on whatever schedule I want, because I'm a freelance and keep doing that in that way, right? So so I'm very happy to be able to work. I guess I should talk a little bit about that. Okay, so as you all know, I've done Linux ports like this quite a few times in the past. My first time I think is when I was like 12 or 13 years old, and I put Linux on the old ISP router I had lying around. I imported UC Linux to it. And but the first big thing, it wasn't even Linux, but the first big thing was the Nintendo Wii stuff, where I was part of the team that basically jailbreak, to use an Apple term, the Nintendo Wii. And we had a whole SDK for running open source software, and then eventually there was like bootloader stuff and recovery, and there was an export done by somewhere else. We worked with them, and that was fun. But that was a lot of work, and there was a lot of drama because there's always people who will take this effort and then use it to pirate games, which I absolutely don't support. Like I don't demonize people who choose to infringe copyright, but I don't want to be associated with them, and I especially dislike the fact that it seemed a lot of these people felt entitled to being given away to pirate games, and that really like burns you out after a while, right? So then we found bugs in the PS3, and we figured, well, we're kind of over the run the entire community stage. That was fun for the Wii, but it's too much work to do it for the next console. So why don't we just release the bugs? And then what happened is we released the bugs, and then nobody used them for anything serious. There was a bit of homebrew software, but a lot of people were just using it to pirate games. And so then on the PS4, I said, well, look, I just want to have fun putting Linux on this thing. And so what I did for the PS4 was I worked on the Linux port, and then I had a binary basically that was designed to make it as easy as possible for anyone who had an exploit on the PS4, which I did, but I wasn't sharing it, to use Linux, right? It was literally like, put this binary in memory, jump to the first instruction, and it will load Linux for you and clean up the software and hardware and everything. And that's fine, but it was fun, and I've got a lot of hardware working. But the main thing is, even in that situation, like, you have a platform where you're playing cat and mouse games against the manufacturer. You rely on exploits, and so your user base is very small because you can't, like, people who want to play games and be online have to update, and then that patches the bugs, right? So you put all this work on it, and it's fun for the challenge, but then you don't get to see a lot of people use it, and there's not a lot of like motivation to maintain it. And so at this point, honestly, after that, I had sort of written off the idea of doing console work. Like, I've gone through all the stages of how I could work on this, and kind of lost motivation of doing this kind of thing. I mean, I could still do Linux ports for fun, but like only to the extent where it's a fun challenge, not to the extent to where I would actually make it into something people would want to use, right? And then Apple shows up, and they go, "Hey, Morgan, here's a machine that doesn't run Linux and is going to be a healthcare project to run Linux on. And also, you don't need to jailbreak it. And if you get it running, anyone can use it." And it's like, huh. Well, now I'm interested. So yeah, I'm actually very, very excited about this project, because this is literally like, it's like Apple solved all the problems I had with every single time I've done this in the past, and gave me the biggest challenge ever, like simultaneously, right? Like huge challenge, none of the downsides, and apparently people trust me enough that I can actually make this my job now. We're at like 60-something% on the Patreon, but that's already a pretty big chunk of my time, so I think we'll be fine. Like, for getting started and everything, like, not an issue. So yeah, I don't know. It's like a very conveniently me project. What can I say? So yeah, really excited about this. Let's see. Which country do I live? I live in Japan. I think I've mentioned this a few times. It's on my Twitter too. Do I have a particular hobby or a favorite car? I don't drive, mostly because I don't have to. I'll get my license eventually at some point, but I live in Tokyo, so we have good public transport here. But, well, originally this was my hobby. And recently I've been getting other hobbies, which is also why I'm really excited to work on this as a job, because it means I could keep doing the other hobbies, right, as a hobby. And I've been making music recently, both live in a couple bands and in like jam sessions, but also producing music, all on Linux, by the way. And actually, I have some of the CDs somewhere. This is the this is like the first test print I made of the cover. That is not the final version of the colors, but like it looks something like that, and the CDs look something like that. And these are CDRs. And yes, people still do CDs in Japan. Japan is still a very CD based like culture that is very based on physical goods, and so these are sort of indie covers of music from a particular game series that has exploded in popularity, and everyone knows I'm talking about Toho. But and like I put a lot of effort into like printing this. Like these are direct inkjet prints, but like I tweaked the alignment so there's no like white rings and stuff like that, and like the quality is really good, even though it's just printed on a Canon inkjet. And these are broken ones that like had some issue, but okay. We have a slightly spammy user. But anyway, where was I? Since I just got about that, yeah. So I put out 2 songs last year, and then another song in September. I'll probably doing some more next year, and I'm working with a friend who does the vocals and some other people. So if you're interested in that, actually, I'll just send you the link in the chat if you're interested in that, because I've got a Bandcamp. I got a YouTube actually. There's a YouTube. This like I feel like this has like nothing to do with like the M1 project, right? It's like 2 different worlds. Like, I haven't even announced the. I have a sort of a separate Japanese Twitter account. I haven't even announced anything about the M1 thing on that one. It's like they're 2 different worlds. But yeah, if you actually are interested in this for some reason, there you go. I do have a Bandcamp. Some of the songs are free, some of the songs are like, you know, token amounts of money anyway. It's all free on YouTube anyway, so you just want to listen to it. And all the songs on YouTube have English subtitles because the songs are in Japanese. The vocals is Japanese, but there's English subs in YouTube, and at least one of the songs, which also has a remix, has singable karaoke English subtitles. The others just have translations. But anyway, yeah, so as far as hobbies, that's pretty much it. Actually, like, I'll probably just show you that this is my rig here, my music rig. And the blue thing, the blue Yamaha mix at the top is the one that I carry to sessions and that I go to anything live with. And the Core Kronos on the bottom runs Linux, and is the subject of some hacking stuff that you may have seen on my blog if you've followed it at all, because there's some fun stuff there. Wait, did the link not make it to the chat? Wait, hold on. Did this like not approve my message because it has a link in it? Like, did it like moderate my own message or something? I'm confused now. Oh, wait. Is this? No, that's not it. Hold on, did the links make it? Oh, they... Huh. So it just pretends to send it and then it doesn't send it? Okay, that's kind of sad. Yeah, okay, so how do I do this? I would have expected at least, like, you know, the author of the video to be able to pin the message, but... Hold on. That's kind of sad. Can I just send, like, a not link? Does that work? No. Can I pin this? Nope. I have it like a different copy of the chat on another window and I don't see anything, so... Did that work? Oh, pin works. Okay. Cool. So that's that, and the YouTube is just maybe it's because I wrote it as text and it at least works like that. Let me try the YouTube one as a link and see if it works. Does the pinned link work? Okay, so I'll just put both there, and then we can. See, can you tell that I'm a newbie YouTuber here? Okay, there we go. So let's pin this one, and then we can fix all the problems now. So hopefully that worked with both of the links now. Does that work? Anyway, so yes, that's my hobby right now. And other than that, let me go back down to what we were talking about. Someone mentioned audio on the T2 Max. Yeah, again, because so I understand that went through the T2 and there's a whole mess. So it's going to be very different on the M1. It's also going to be hard, but you know. And yes, of course, anyone who hasn't seen my Patreon yet, this is an open stream, but I will be doing some sort of Patreon-only streams for more personal stuff. And yeah, the Patreon link, if I remember correctly, is in the description of this video. It is, yes. So if you're interested and you're not a Patreon and you feel like this is a project you might want to support, please do, by all means. Anything and everything helps. VTuber Marken when? And she said the same damn thing. Will there be a Twitter account to follow up to the project? Yes. If you go to Twitter and just Twitter/Asahi Linux, that is already registered. We have the GitHub and the Twitter. I haven't even set the profile icon yet. I don't have a logo for the project yet, but I have some people that I will be working with that on. So hopefully we'll have that soon. And a bit of an identity and a website. I also have the domains registered. So yeah, it's just missing like content and setup, but the accounts are there. What happened with lasers? I mean, I have lasers. Like I have a bunch right there. That's also a hobby. So actually, that goes together with the music. I'm interested in making music. I'm interested in stage technology in general, not just lasers. These are just DMX devices. But I've been playing a little bit with stage equipment because I want to work on things like integrating these things with OpenLays and with other stuff and doing like, sort of more produced stage kind of deals. So it's also related to all the music business, but from a different angle. What camera am I using for the streaming? This is a Logitech C... What was that? 9... What was this thing? I named the UDEV rule C910. Logitech C910. I think the C920 is the new common model. Or C720 was it? Yeah. This is C910, right? And actually, the reason this is a C910 is... Yeah. Is that I got a C920. And I think she's meant the C920. Yeah, the reason why this is a C910 is that I got a C920, and then a friend of mine had a broken C910, and I'm like, "Oh, you just use mine. I'll figure out what's wrong with yours." And I took it apart, and the USB connector had literally ripped right off the board. Like the cable was so thick and like put so much tension on the connector that it just ripped off the solder pads, but didn't rip off the pads off the board. It just ripped off the actual soldering, so I could just fix it. So yeah. but I think it's almost identical to the C920, just a minor upgrade, so it looks fine. And also I am doing this in my studio / bedroom, but at least I'm trying, because the only reason I look decent is because I got a video light. Otherwise, I would look like this. So at least I'm trying. So hopefully that's a lot better. Actually, I got like a slightly too big video light, and I don't have a good mount for it. So instead, it's behind my screen, pointed at the wall. I'm getting like the diffuse reflection from the wall, which works quite nicely. So yes, lighting is important. And also, like, the microphone is a bit far away, which is why the audio isn't great. But at least I have a gate on it and some audio processing. And I actually, right before the stream, I put it on rubber bands because I realized like the arm was transmitting vibrations from my laptop, and it's like, I just hang it like on that. Very ghetto, but it mostly works. So yeah. I mean, I know this is a thing in proper mic mounts, but I have one for my condenser mic, which is somewhere else right now. But I needed something that works now. Yeah, I got this microphone. It's a Behringer clone of the SM58, the MX8500. I bought it for like $3 at Hard Off. Like literally that. Like I was just like, hey, they have a mic. It looks fine. I'll buy it. If it's junk, I don't care. And it worked just fine. So I've been using it for all the Animentop streams and other stuff. Like for everything but recording vocals, it's just fine. And I spent like $3 on it. It's great. I have an AT2025 is the proper condenser mic I have, and I used that to record vocals a long time ago with a friend. But my current vocalist for all the songs under Tsiolka Circuit actually does her own recording. Like she has her own mic and everything, and just goes to the studio and does it. Like seriously, she's so good. Like I sent her the reference stuff and the lyrics and the sample, and then she just shows up with a complete cut up recording, and then I just tell her fix these two little things, and she does, and it's done. It's like it's so great working with a vocalist that understands the technology, and she can just do it herself. Mic is in frame now slightly, yes. As for actually, I didn't set this up for streaming my screen, but I guess I might as well do a little bit of showing off of how this works while I'm here. So let me pull up screen capture. So normally, actually, when I do my work streams, I will be streaming some of my reverse engineering and driver writing code and all that stuff. And when I do that, what I will actually do is run OBS on a different machine, and I will take an HDMI like mirror of the iMac screen and stream that. And the reason for that is that I want to be able to use the setup without having OBS take CPU time. Not that important for reverse engineering, but it is important for if I do like a music stream or something like that. So I have one of these Chinese capture cards. And actually, another project I have is I need to reverse engineer the command API on these to figure out how to turn off a freaking sharpening filter, because it's not a standard control. But it should be doable. I already have some firmware for them and some Wireshark traces. But even with the sharpening, it's not terrible. But the way I'm doing this right now, I guess I might as well just share my screen and show you. Let me make sure this is fine. Is something like this. I was doing so a friend of mine created a DJ event last year, and the first event. Oh, did I break something? Hold on. Huh? Did Oh, sorry. Okay. I forgot to add the audio to the other view, so that's why. Because I just hacked this up right now. So I guess you saw me explaining the audio setup, but you didn't hear me explaining the audio setup. So I hope some of that made sense. Yeah. The scene didn't have the mic, yeah. Because I just created it right now because I wasn't expecting to do that. Carla is a plugin host. Like, let me just go back and let me just redo that now that I have audio. So hopefully audio is still a thing now. So Carla is a plugin host. It's just a container for plugins. There are equivalent things for like Windows and Mac too. And so what I was saying before with no audio was that I have a gate, because otherwise you can hear all my background noise if I turn that off. And then I have a compressor, because you need to have a compressor on vocals, because otherwise your levels are all over the place. A limiter just to make sure I don't clip, but in this case, this is more useful when there is mixed audio from something else. Otherwise, it's, just the mic isn't going to clip. And some EQ to clean up the audio a little bit. Ooh, that just glitched in an interesting way. There we go. Yeah, my dad is telling me that you can hear me now. And I guess my dad's watching. Hi, Dad. And I had a bit of off right now. The reverb is more useful when I get really close to the mic like this, because then it's like ASMR land. And so to make it sound like you're a bit further away from the mic, you turn up a little bit of reverb only. But in this case, it's completely turned off. So I will use that probably when I do the work streams, and the microphone will be closer to my face in that case, because I won't be using the camera. But yeah, so that's what I use Carla for. And this gets a lot more complicated when I do DJ streams and things. So here's a little story. A friend of mine started a DJ event here in Tokyo. The planning started last year, and our first event was in January this year, and I was doing lasers. That's why OpenLace got a bunch of patches in January. I had two lasers. I was basically doing like live VJ style, sort of, improvised laser beam effects at that real actual venue. And then the pandemic hit. And then we were like, well, what do we do? And then, of course, what we did is move to online, as everyone does. So that's how I ended up learning how to use OBS to do interesting things. And, well, I wasn't going to do lasers for an online DJ event because we were doing restreaming, right? We're not doing the thing where we get only the performers in a venue and then stream the whole thing. No, everyone streams from their own house. And then someone has to take all those streams and put them into one and, like, make transitions work, right? And of course, I signed up for that. So now I'm doing like MCing and transitions, and I have this extremely complicated OBS setup, and with like Python scripts and a controller like this. And so we actually just did a little presentation with Shiz and a couple of other folks. Shiz is over here in the chat too, watching, who do similar streams. Where we talk about the technology and what we do, and so one segment of that is mine. So let me find you the link to that. Yes, this link. So if you're interested in, of course, Google messed up the link on this. Hold on. I hate it when like the link preview and Google search results is the proper link, and then you right-click, copy link, and you get the freaking tracking URL. So hopefully this works if I pin it. Does that work? Yeah, so if you're interested in this kind of technology about like using OBS for a complicated setup with transitions and doing a professional production and getting multiple inputs and outputs and audio processing and how to coordinate with people and all that stuff and RTMP servers, 4 of us got together and made a little presentation covering all the different aspects of that. So if you're interested, take a look at that video. One segment is mine, and I show off the Linux thing and how you transitions and all that stuff. It's pretty fun. All right, so to reverse engineer the waveforms we saw in order to recreate the sound. Yes. Faster PCI than Thunderbolt provides. Do they have 4.0 on the raw PCI pins? Maybe, but I mean the thing is, given the way they do their boards, that doesn't sound very fun, does it? I mean, you could take off the SSD probably, but then again, the bootloader is going to be very unhappy about that. So I mean, you could take off the Thunderbolt chips and get the raw lanes. If they are 4.0, then maybe. But I mean, would you really want to do that? I mean, for the hell of it, sure, why not? But, it doesn't sound very practical, does it? I've been working on a new demo recently. No, I work on demos like the week before events. But I think a new Tokyo Demo Fest is going to happen eventually, and I'm probably going to end up being staff on that because somehow I end up becoming staff at demo events. So, let's see. Will I be streaming the work? Yeah, so not all of it. I'm not sure yet what percentage of the work I will stream, but I will stream some of it. I'm thinking of making it semi-regular at some point. And I guess over time I'll figure out if it's going to be most or just a few days a week or, or something like that. But I will be doing work streams to some extent. Just haven't decided exactly what extent. But I want people to see what the process looks like. And I've done a few of those in the past for other things. And I think it's very useful. I just need to figure out how painless I can make it so it's not annoying for me to do, and how comfortable I am with doing it for most of the work that I do, just out of like times and feeling and that kind of thing. But yeah, if it ends up being something that I get used to doing all the time, then it could be a lot of the work ends up being streamed. So let's see. Okay, there's only Thunderbolt retimers. I thought they were controllers. Okay. Interesting. For someone who is newish to getting Linux to work on unsupported hardware, any recommendations on where to start? Books, websites, tutorials, frameworks, tools? Every time someone asks me this question, it's like my answer is just do it. All I can say is like I learned everything I do by just doing it. And doing it is 30% Google skills, right? Just learn to search for the information you need to do it, and then just do it. So, really, you could try working on Linux on usually you want to start by looking at what other people have done, right? So look at how the code works. Run Linux on some random device that you think is interesting, that already has a port, and see how it's done. Or of course follow what I'm doing here. But it's the kind of thing you learn by doing, and I've never used any book or anything like that as like a big part of how I learned anything, really. I have a few token O'Reilly books because every programmer has to have some O'Reilly books, but I don't think I've ever read more than like 10 pages of any of them. It's mostly been just searching the internet and doing things, really. And trial and error sometimes, or sometimes just, occasionally getting someone who knows what they're doing to teach me some concepts. Doesn't happen very often for me. Like that's an actual mentor thing, not like just asking questions to people. But you do need to ask questions, ask a lot of questions. And yeah, just try things. Like if you want to port Linux to something, you should know how drivers work, right? So maybe try writing a driver for something first. that kind of stuff. But yeah, basically, don't be afraid to just do things. Just try. Just like dive headfirst into something. Wait, the SSD controller is packaged with the RAM? Oh, the RAM, but the controller, you mean? Yeah, no, you mean the SSD controller has the RAM for the controller as POP? Yeah, yeah, I can see that being a pain, a pain in the ass. Yeah, curious about the days when nothing works. Yeah, so probably this coming next week, I'm going to be doing a bunch of work on the serial, and that's also going to involve physical hardware. So maybe it's a good idea to see if I can just get the camera pointing at it and show that process. That might be fun to get on camera. And then after that, there's all the load that will bring up, right? Yeah, sure. I'll give it a shot. I'll see how much I can get on camera. It just means I need to make sure I wear pants. And yes, absolutely. When I do work streams, I won't be able to follow the chat all the time because if I do that, then it would really be a distraction. So probably a lot of the time, it's going to be just unidirectional in a way, and then occasionally looking at the stream, unless I get stuck on something, and then I'll see if someone is nice enough to tell me where I fucked up, as has happened a few times in previous work streams. But yeah. Initial bring up the manga guide to Linux porting on a hostile target platform. You know, I have a few fun books, and there's the manga guides, and like these are, I have the Japanese. Let me show you some fun books actually. Give me a second. So, yes, someone mentioned that you're talking about this, but it's not actually a manga guide, unfortunately. It does have a very cute cover, and the title is Kitsune-san de mo wakaru LLVM. Basically, even Miss Fox can understand LLVM. So it's not actually a manga guide. It's a proper reference book, but it has like some cute little images thrown around in like the titles of the like the first page of chapters and things like that. I haven't read it. My Japanese is not good enough to understand this, but I had to buy this. I think I bought this like when I first visited Japan, actually, before I even moved here. But it was too good not to buy. Yeah. And but also, you do know the manga guides, and this is the manga guide to cryptography, which is great. Like it's like this is proper, DES key schedule stuff, whatever. Talking about DES and then AES later, and you get S boxes and all this other stuff. Like, and this is actually like pretty damn good stuff. It's all very cute, and I believe this is already translated into English. And this is the manga guide to CPUs, which also is like proper computer architecture stuff. Like here's some ALU operations table. I don't know if you can see that. But I bet you don't know about these. This is the Sysadmin Girl series, which is also Manga de Wakaru Linux, like the manga guide to Linux, but it's not from the manga guide series, it's a different series. And yeah, like the first few pages, there's a bit of backstory about joining a company and that stuff, but then you get to the actual like sysadmin stuff. And the first few pages are in color, which is great. And yes, this is actually Linux Mint that she's using there. And you get stories about like SSH clients and like X tunneling over SSH. and it's talking about like, you know, X forwarding and all this stuff. But yeah. And then it goes into, I mean, you get these cute like Halloween pics and stuff. It's really good. But yeah, after the first few pages, it goes black and white. But also, you may have noticed that these are manga, but they are indeed in Western order. They read left to right, because technical reference books are usually left to right in Japan, and this is the rare case of a technical reference manga, so it is indeed left to right manga. As strange as that may sound in Japan. Yeah, like red mine issues, and there's a second one, by the way. That's Sysadmin Girl 1, and this is Sysadmin Girl 2. More SSH Linux main stuff, and Vim, and whatever. Cron tabs. So yeah, lots of interesting books around here. At what level do I speak Japanese? I have not taken the proficiency test. I've almost since like 6 months after moving to Japan, my job has been all in Japanese, which doesn't mean my Japanese level was good. It just means that I could use a lot of English terms because it's IT anyway. Like when I do freelance for the main client that I have here in Tokyo. But I only semi-recently got to the point where I'm comfortable enough having written conversations with Japanese people without too much trouble. Like I can tweet in Japanese and reply, and I'll make mistakes but don't sound like a total idiot. Because it's actually kind of hard to get comfortable to that level. And I've been in Japan for 6 years now. But basically, I can converse in Japanese. I make mistakes. I'm getting better. I can fumble my way through complicated bureaucracy with a dictionary when that needs to happen. And if it's written, it's easier because then I can just, if it's a website or something, I can just use one of those dictionary plugins and stumble through any kanji that I don't know. But yeah, like for the DJ events that I MC, I do the Japanese intros in Japanese, and I've been practicing pronunciation a bit too. But yeah, I mean, I don't know. Like I can live in Japan. How long did it take me to learn Japanese? I studied for 1 year with a private tutor before moving to Japan. Plus a bit before that, sort of learning on my own, and like that was enough to survive in Japan basically. And then you sort of get the whole immersion thing, and then usually what happens is you get really good, like you improve fast at the beginning, and then you kind of plateau, and then you have to force yourself to improve again and actually talk to people and stuff. So it was kind of this kind of thing, right? You know, it starts here, and then there's a big thing, and then it stops, and now it's getting a bit better in the end. Helps a lot if you make some Japanese friends that you can actually talk to about normal stuff, not just, IT things where you're always using the same words. Like once you learn the Japanese word for reboot, well, you know how to say Saikido. But everything else ends up being in English. LibreOffice tabs, the browser tabs. Oh, you meant in the manga. Vocaloids explaining Diffie Hellman. Is that a thing? What do I need to put into Google to buy this? The manga guide to CPU and cryptography. Those are translated and published, I think, by, was it No Starch Press? So you can just search the manga guide and you'll find the translated versions. If you want the Japanese ones, I mean, they're on Amazon JP. You can get them for Kindle, I think. I don't know if you can get them shipped. Probably. Audio dropped? Huh? Or is that something? I think you sent me something else. I think it was a previous message. But yeah. What was I saying? If you... So the Japanese... The Japanese title for the series is, make sure I get the exact writing system, is that. So if you search for that on Google and on like Amazon COJP, you should be able to find the actual Japanese versions for, I believe, for these books. Yeah, so this is everything, right? So you need to search like for CPU or something, and then you get the CPU one. And they do have them for Kindle, and you can probably get them shipped if you really try hard enough. Oh wow, there's a manga guide to digital circuits. I didn't know that was a thing. Sounds like fun. And then if you search for Linux, this is Happening Girl series. There's a 3 now apparently. So that'll get you on Amazon COJP. That'll get you the Sysadmin Girl series, which is also available on Kindle. Oh, there's a Git one now. I didn't know that one. There's I think this is a different publisher too, but there's apparently a manga guide to Git. So, yeah, interesting. HTTP channel, UDP channel. Yeah, I have. Yeah, there was like a networking page in the Sysadmin Girl thing too with protocols, I think. Where am I originally from and why did I move to Japan? I'm Spanish. And I moved to Japan because I like it here. Because I've lived in, like, what, 4 different countries now? And when I visited Japan, it was like the first country that I felt like I actually wanted to live in as opposed to just happen to incidentally live in for some other reason. And so I moved here. And I probably will stay here because I don't see myself going anywhere else, really. Does Studio work on Linux? I don't know. I actually have a Surface tablet upstairs that has a busted screen that I got from a friend, and it has Clip Studio, and I'm thinking if I just fix the screen and mess around with that. But you don't want to see my drawings. Like I am like completely useless at that. Yep. How do I maintain permission to reside in Japan? Well, I'm freelancing currently, and until now, most of my income has in fact come from Japanese sources, which is enough to qualify and continue to qualify for an engineering visa. Now that this project is starting up, I already have a reference that I just got from an immigration lawyer to figure out what the best way to make this work. I'm sure there are multiple approaches, and I'm sure I can work something out. But yes, that is indeed a thing that I have to deal with. I actually have a visa for a 5-year visa I just got this year, so it's not going to be an urgent problem right now, but I want to make sure I don't screw things up later for like the next renewal, so yeah. And yes, Japan has excellent public transit indeed. Not highly skilled professional. For that, actually, you pretty much need a salary, and I wonder if I could sell the Patreon as a salary. But because I've been freelancing with variable time, I can't prove I can't prove a salary which is required for an HSP visa. So I just have a regular engineer visa. Online freelancer or offline? Both, but most of my work has been like in office until this year, and then we went full work from home. And that's like a long-term client that I have here in Tokyo that I don't actually intend to drop. Like if the M1 project reaches like full-time level, it'll be more like I'm there for them if they have an emergency, but I'm not going to be spending significant time on projects kind of thing, right? So it's not going to take time off of the M1 thing, but I'm not going to literally drop them because they're actually very nice people. And have been very helpful over the years. So like they're kind of friends besides a client at this point. But yeah, the main thing with the HSP is it has to be like an actual salary effectively that you prove, I believe. But yeah, if you go over SHSP, you can get permanent residency in like 1 or 2 years, which is great. Which is why I don't have it yet, even though I've been here 6 years. But by the time my current visa expires, I can apply for PR. So I just need to make sure I don't screw that by doing something wrong against the rules now. But yeah. Am I planning to work on other Linux projects, for example, the Surface Pro line? Well, I have that Surface Pro that I did put Linux on an SD card. I don't know. I mean, you know, the new thing for me here is that I'm doing this as a full-time job that, you know, people are contributing money towards. So that's a different level of motivation. Why did the freaking Google thing trigger? That's a different level of motivation from the way I normally do things, which is that I just work on whatever I feel like. So I can't tell you, will I work on X, Y, or Z, because if one day I decide to do that, then I will. Otherwise, I don't. And I won't. Which is also the same for the iMac, right? I do want to fix it, but it's not the M1 project, so it's whenever I find a slot for that. But yeah. Could I build my own Japanese company that would salary me? That's not for the HSP purpose what I'm thinking about that, but starting a company and getting, you know, the visa permission that way is one possible approach to making this work. Yes. It all depends. Yeah, Google heard money. Well, Surface Pro 4, I believe, is the one I have. And it has that screen problem that is endemic, and there was a replacement program and it's past the deadline and I can't get it fixed now, which is lovely. But the funny thing is, I was thinking of using that Surface Pro 4 for like music stuff, for live events, for going to places. And now that the M1 thing is happening, I'm thinking, well, I'm very, very interested in the M1 devices for audio, because they probably have way better real-time audio performance than any PC. Because PCs are hideous, complicated devices with a ton of horrible things running in the background that screw with your real-time performance. Like, you know, the firmware will do things like put like there's basically a built-in hypervisor on every PC that will steal your CPU whenever it feels like it. Like, no joke. And that kills real-time performance badly. I assume M1s don't have anything like that. And usually embedded platforms like this have way more predictable, you know, hardware and like power change performance and all, like power level switching and all that stuff. Like Intel CPU seed states can be pretty unpredictable. They have too much junk running in the background there these days, doing all the frequency state switching and all that stuff. So I'm very, very curious to do a side-by-side comparison of an Intel laptop and an M1 laptop once I get to the point where this USB works is really all I need for some kind of audio stuff with an external interface. And see how low I can crank the buffer size and still get good performance. I'm very, very curious about that. But if that all works out, I might end up making the M1 MacBook Air my gig machine. Or even the Pro if it's one of the higher requirement projects. So we'll see. What are the main high-level roadblocks in bringing Linux to the M1? Have you watched the rest of the stream? Because that was kind of what the whole thing was about. I use an Android, and I'm in the process of switching phones because I just got a Pixel 4a 5G. And I'm deciding whether I want to just root it in the use original OS for now. What I want is Lineage OS, but it's not ready yet. And since it's not ready yet, there's an unofficial port, and I'm not sure how much I trust it, or whether I just want to use Google and throw some kind of root on it for now. Basically, I want root because that's my backup, restore, and get things in the right state system. So I want Lineage OS, but at the very least, I want root so I can transfer data over in the ways that I know work for my stuff. So yeah, this is my old phone, which is pretty busted now, and I definitely need to replace. And then there is a nice little Pixel 4a 5G here, which is currently just like blank. I just turned it on and set it up, but there's nothing running. And we'll see about that. cool. Yeah. The thing is, I never find myself short on projects. I have an infinite back burner project stack. So there's always something that I should be doing. So, but then again, I always get distracted with new things too, so who knows. Computational audio on an MCU. Yeah, that sounds fun. Actually, I want to try writing audio plugins. One thing that interests me is speaker calibration. I know there's Room EQ Wizard, which is kind of the manual way of doing it. And then there's SonarWorks, which is the proprietary thing that they have a Linux version of the plugin, but not of the calibration tool. But I like what they're doing, but I'm not. It's like I feel like their thing is too automagic and doesn't actually let you understand what it's doing and how the room response looks. So I feel like one of these days I want to try effectively cloning what they're doing, but with more of a power user perspective and getting like nice graphs, or like, once you sample the rooms, like, well, here's the sweet spot, and do you want to optimize for the center, or do you want to optimize for a more average response or something like that kind of thing. Like I want that kind of control. So I would like to see if I can write a plugin along those lines, like an LV2 plugin along those lines one of these days. But it's one of those ideas we're doing someday. I don't have a plan for when I'm going to start working on it. What makes me a successful person in my career? I don't know. Being interested in what I do and having good knowledge acquisition skills, I guess, if I had to sum it up somehow. Like, the most important part is not what you know, is being able to learn new things and to find the knowledge you need to solve a problem. And I think I'm pretty good at that. Also, if you just want to speak about sort of show off, I'm good at X particular area. I'm good at debugging horrible, complicated problems. I have a bit of a reputation for that. Especially like drive-by debugging. I fixed a bug in OBS for the event last weekend that had been going on for 3 years. And the developers didn't even understand that it was a problem. And I got sick of it because it crashed my previous like DJ restreaming stream multiple times, and I just sat down and I'm like, I'll figure out what I found a way of reproducing one of the triggers, and after that I could I found multiple problems. I actually at one point I was 4 bugs deep. Like I was debugging this bug, and then I found this bug, and then while trying to fix that bug I found this bug, and then while trying to fix that bug I found this bug, and so I was 4 nested levels deep in OBS bugs. But we went back to I did pop that and pop the stack and fix everything. Yeah, infinite work works. Will your porting efforts support the image processor and the M1? At some point. Again, it's one of as I mentioned before, like everything's in scope. The question is what comes first. But probably not top priority. I'm more interested in the video decode first. But we shall see. Yeah, procrastination. I haven't seen the Wii schematics, but is there anything interesting there? The Wii is actually a very simple console. Like, the board has nothing on it. Have you seen the people who are, like, cutting down the Wii board? There's one person who is already, before the schematics, building a custom Wii PCB. Completely custom. Like, the Wii is actually, it's amazingly simple. There's nothing on that board. It's got the PowerPC, the GPU, and then, like NAND, RAM, flash connected, and it's like a minimal amount of power supply circuitry. Like, it's also obvious. There's nothing on it. The Wii is beautiful to look at. Like, the board, it's like, there's no fluff in the board. It's like the exact opposite of the PS3. So yeah, I don't think there's anything about the Wii that we wouldn't already know, because anything that had to do with schematics that we needed to figure out, we already did anyway. I have friends who even did like delayering of the PCB to get trace maps out of it and things like that. But yeah. Have I ever heard of Spanish game developers Gaelco or Ziggurat Software? I have not actually. Or Dover and 6080? I have not actually. Oh, the dev transition PCBs are also empty? Yeah. Oh god, Ridley, do you really want me to talk about the PS3? Okay. The original PS3 board. The original one. The first one. That thing had... Of course, it had the cell and the GPU. And they had a PS2 in there because we know they did that for the backwards compat. But like, that's the stuff we know. That's the documented stuff, right? Let me tell you how they did. Where do I start? Okay, so the South Bridge. The South Bridge, as far as I can tell, was some kind of like set-top box chipset with a whole MIPS CPU and RAM controller, none of which they were using. I'm told it had more silicon die area than the cell. Like, no joke. That thing was expensive. And like, so then that thing has PATA ports, and then they had a PATA serial converter for the SATA hard disk. And then that thing has like GMIA for Ethernet, right? And do you know how the network works on the original PS3? It's Wi-Fi and wired, right? So wired is straight on the South Bridge and Wi-Fi is on USB, right? No, of course not. The original PS3 has an entire wireless router running ECOS on a Marvell chipset with Ethernet connected to a gigabit Ethernet switch with VLANs, which is connected to the South Bridge and to the external port. And they use VLAN tags to separate out the external Ethernet port traffic and the Wi-Fi traffic on the internal interface. Yes. I don't know why. And then there's the whole video path through like the Emotion Engine and the GPU and some weird stuff to get the video out that they did there. And there's a card reader in there too, though I think that was just USB. Oh, and then there's the NAND flash. They have a custom NAND controller, and they put the whole OS on NAND instead of the hard drive. Why? I don't know. Like, there's this whole weird custom Sony flash controller. That board is insane. And as far as I can tell, what happened is basically they had a dev kit, and then they shipped the dev kit. Like, they had a dev kit, and then they removed everything they could remove without breaking things, and everything else is the dev kit architecture. Then later, the later revisions replaced the flash with NOR flash and put the OS on the hard drive and replaced the Wi-Fi with normal like USB Wi-Fi, and then on the PS3 Slim the Ethernet was just directly connected to the South Bridge, and that, by the way, required changes to Linux because then there was no VLAN tag anymore. But yeah, it's basically rushed hardware with no optimization for cost or manufacturability, and then they just eat the cost. So yeah, it's bad. Why leave Spain and come to Japan? Well, I mean, I was working at Google before moving to Japan, and I left because I wanted to move to Japan, and the job I wanted wasn't here, and I was a little bit tired of Google at the time. That was kind of the Google Plus era. But I mean, as I mentioned before, I'm in Japan because I like Japan. So offering me a dream job in Spain is unlikely to be a dream job because it would involve A, being a full-time job, and B, not being in Japan, which are two things that I'm interested in right now. So like my idea of a dream job is, a freelance gig in Japan. Yes, please talk about Toho merch. Please talk about Toho merch. I mean, I've got Toho merch. It's too bad that this is the wrong room, because in another room I have like an entire row of Toho plushies on a shelf, but unfortunately not here. But I have her. So and this is, by the way, I mean, this is a Flandre t-shirt, and this is a Flandre like Parker. So And there's still Homer chanting in the background, indeed. Yes, cable modems with ECOS. I had a cable modem with ECOS too, once, but not dual core. Those are fun. With like the router on Linux and ECOS for the modem, right? Why didn't I update daily, weekly? What do you mean? Like for the Patreon? Am I counting for the next CCC whenever that'll be? That depends. See, I've been slowly less interested in CCC because it's like grown too big and lost some of the charm that it used to have. Like if I lived in Europe, then I'd still go. But it's a bit more difficult for me to justify it living in Japan. And so I will probably go if I have an important talk to give. But if I don't, then maybe not. I don't know. Depends. What are my thoughts on Ghidra? Is it better than Ida Pro? Well, it's free. So there's your, bank per buck win. I switched to Ghidra. I used to pay for Ida Pro. I never paid for the decompiler because it's like such a ridiculous amount of money that unless I'm doing a massive reverse engineering project, it's not worth the cost, and that's not usually what I do these days. But like I paid for Ida Pro, and I stopped doing that because Ghidra came out, and because honestly, like the Hexray guys are a little bit annoying. like they don't treat their customers that well, and I think they've been the only game in town for too long now. So, I'm happy to switch to Ghidra. I mean, I've heard people say that Hexrace is still better for some things, and probably, but I mean, like, is it better enough to spend the money on it? Not for me, maybe for some people, but I will be using Ghidra for anything related to the M1 project. In fact, I already have, I used to have Ghidra open. I just closed it before, so I wouldn't drop frames. But I was looking at the USB PD controller firmware for the M1 Max to see if I can find the serial stuff. Well, I haven't actually started like really looking for anything. I basically cleaned it up. I did like loading the file and finding the load offset and cleaning things up. Tohoku. What did I do at Google? Site reliability engineering. So basically, DevOps++, keeping things running, or breaking them on purpose sometimes for testing. Those were fun. I ran my team's dirt exercise one year, which is the sort of we take a data center down so that we find out who depends on a single site, and then we shout at them thing. But that was a lot of fun to write. Actually, yeah, I'm going to share something fun with you. I don't think I've ever leaked this publicly. I've never linked it like on Twitter or anything like that, I think. But I have linked it in like, open IRC channels and stuff. So it's not like a huge secret. So when Googlers do dirt exercises, Ridley, stop spoiling things. When Googlers do dirt exercises, like these disaster recovery exercises, there's kind of a tradition of basically SRE fanficking them. So you make up some story about why the data center is down or whatever, right? And just throw some fun into the whole test. And I was doing this, and I'm like, I gotta write something. And I think I wrote most of this like on the way, like on the 5 minutes walking to work on my phone. I started writing. I came up with the idea and started writing the first emails, and then it sort of went from there. So this is the censored. There shouldn't be any secrets in here, any Google secrets. But some of you might enjoy this. So there it goes. That was kind of fun to do. Freelance lets me reside in Japan is what I mean. I don't care if it's overseas, as long as like the visa thing isn't a problem. Yes, getting X-rays to take your money is always annoying. Oh yeah, the Ida Home thing. I don't understand Ida Home. Like what? why that product doesn't make any sense. But yeah, Binja's fine. I actually I bought Binja right before Keter dropped. Right before Keter got announced, I bought Binja, and that was before the compiler. But then I neglected to like download the latest version before my support expired. But that was fine for like a few experiments, and I would have kept using it if Keter hadn't dropped. And I still actually Binja is nice for. I will keep using the version I have. Like it's nice because it's small enough to drop in a target if you want to do something on a target in a pinch. Oh yeah, the last Google fail was rather interesting. Oh wow, they that's what they did. They added hex rays. At least that's vaguely interesting. It makes more sense. But yeah, like I honestly, I mean, it's like I've been working without hex rays all this time. Ghidra has a decompiler. I don't care if it's not as good as hex rays because I wasn't using hex rays anyway, right? So, yeah, no, Ghidra's fine. Actually, the other day, yesterday, when I was doing the firmware bit, I just wrote my first Ghidra script, and it was very easy. So, yeah. Okay, I think I should be getting some sleep. It's 5 a.m. here, and I do actually have something to do at like 10 a.m. So in like 5 hours of sleep is what I have left. So if you have any other quick questions, I can try to answer them. Otherwise, I think it's about time to wrap this up. It's been 3 hours. Yeah, what's time indeed? And it doesn't help that I have like all these lights turned on and like it's gonna keep me from falling asleep properly. Well, if nobody asks anything, I think that's a wrap. Thank you so much to everyone for watching, and we still have somehow 200 people, which is pretty insane. Like I would have expected the numbers to drop a lot by the time we got here, but the graph has barely dropped. Like it peaked at 300, and now it's like 200 still. So yeah. Awesome. I will be doing work streams. I will be doing Patreon only like streams like this so that we have fewer people and just so that we can have some more personal stuff. And I will be doing also open community streams like this. At least this is a good test that like at this level of participation, the chat is not insane. So yeah, this should be a regular thing. Not sure yet exactly when, but whenever it makes sense, at least. Cool. Thank you so much, everyone. Someone asked if I have ever had an Amiga. I have not owned an Amiga, but I have a lot of friends who are very much Amiga people. All right. Take care. Yeah, okay, that one guy talked about his hentai, but that was I can deal with that amount of weirdness. Good night. See y'all. Bye-bye. See you next time.